All right, we're good to go. So I welcome the distinguished guests and the young Turks and everyone else who is destined to have a great time today on a cold winter morning. So on behalf of the Academy of Continuing Education, I welcome you all to the grand finale of this exciting analytics Olympiad. And of course, I congratulate all of you finalists for having made it till this point. And of course, only some of you can emerge as champions, but all of you are winners. So let that be, established at the outset. So the Academy of Continuing Education at Shiv Nadar University is the university's gateway to academic excellence to the world. Through ACE, we offer premium executive programs, distance learning, and professional skilling, certifications as a form of continuing education for greater professional success. We are offering several interesting programs right now as we speak. One of them is a purely online MBA degree program. And then we have another variant of the MBA, which is an MBA executive program. And that's meant for people who can dedicate time to weekend classes, physical class on the weekends. And the modalities are different. A lot of the elements are the same. And I will talk about the theme in a bit. And we have a robust certification program in data sciences. So it's called Data Science and Analytics for Business. Now, the one centrality across all three, whether it be MBA Online, MBA Executive, and Data Sciences, and in fact, the other programs which are offered by the Academy of Education and the School of Business, we focus on the technology entrepreneurship. So it's basically pivoting the entrepreneurial axis in the digital economy to successfully navigate through the landscape of the world of tomorrow. And that's the vision of our dean, that's the vision of our school, and that's the direction in which we are headed. So therefore, as an institution for promoting and delivering high-impact academic programs, we take great pride and interest in organizing competitions such as this. We had a great competition last week called InCube, and this time we have another one in the form of this Analytics Olympiad. This one has been a maiden run for us, but a definitely exciting one, and we hope to take it forward to the next level with the years to go. And so it is competition like this that enable us to challenge the technological and business frontiers through the collective intellect of fresh minds such as yours. So without any ado, let us now introduce people to this August gathering. So first of all, I would like to welcome the jury members who are here. And let me just give a brief introduction so you know that you are being judged by people who know the business. So we have, okay, so let me do ladies first. So let me go with Dr. Swati Jain. Dr. Jain is the Vice President of Analytics at EXL at NASSCOM in 21. She has been recognized as being among the 50 most influential AI leaders in India in 2021. Also among the top 11 women analytics leaders in India 2020 by the Analytics India magazine. She holds over 2 decades of rich experience in research, analytics, and consulting for diverse domains such as financial services, retail, healthcare, pharma and logistics, domains across customer, marketing, risk, and operations analytics. In the past, she has held senior strategic roles at Cognizant, People Research, Ernst & Young, and Polyplex Corporation, and has received multiple leadership awards in these organizations. She holds a PhD in economics from the Indian Institute of Delhi, and a master's in business economics, MBE, from Delhi University. At EXL, she led the award-winning submission for NASSCOM AI Game Changers Awards 2021 in the logistics category. She has also co-authored multiple white papers and conducted several webinars on data science, analytics, and has served as a speaker and panelist in several events for NASSCOM and TICON. She has a unique specialization and grasp of the various facets of market and business research and associated databases. So quite an impressive repertoire. I welcome you. Next, I would like to introduce Dr. Anish Agarwal. So Dr. Agarwal is the Director of Data and Analytics at the NatWest Group. Prior to that, he has held senior leadership roles on the forefront of data science and research across organizations such as Clifford Chance and Vertex. He has over 20 years of experience in multinational organizations with a proven ability to design and execute strategy and new technology adoption. He has been recognized among the top 100 influential leaders in Asian analytics industry and top 40 under 40 data scientists in India. He has presented technical papers and keynote addresses at numerous professional conferences and universities on artificial intelligence and data and analytics. He has held several positions of immense organizational importance with principal focus on delivering value through innovative use of data to drive decision-making. Dr. Agarwal holds a PhD in computer science along with an MBA degree and has completed several programs from premium business schools such as Harvard and MIT Sloan on the subjects of AI and disruptive business strategy. His unique forte is that of being a stealth leader and synergist, whereby he can connect downward, upward, and across to design business models that actualize the value. Welcome. Welcome, Dr. Agarwal. Next, I would like to introduce another lady, Megha Sinha. Megha is the Vice President for Digital at Genpact, where her role encompasses leading initiatives using the power of artificial intelligence, machine learning, and operations. Megha is an MBA from IIM Ahmedabad and has over 11 years of experience in data and technology strategy and consulting. At Genpact, she is responsible for AI and ML solution, frameworks, consultative offerings and initiatives for clients, and driving the market-facing growth strategy for the organization. Prior to joining Genpact, she has worked with Accenture for a decade, where she led cross-functional teams, managed client relationships, and led pre-sales and solutions in cloud transformation, data engineering, and data integration for enterprise applications. Wow, that's a lot of technical jargon for me, so I got tongue-tied. So welcome, Megha. It's great to have you here. And our final jury member for today is Manoj Madhusudanan. He is the head of Dhanambi, India, and widely renowned as one of the top 50 visionaries in artificial intelligence in India. He was also the founder and CEO of an AI-driven B2B platform that helps optimize sales targeting. Prior to that, Manoj has held strategic leadership roles in organizations such as eValueServe and Accenture. With a solid academic foundation in engineering from IIT Chennai and an MBA from XLRI Jamshedpur, Manoj has the right technopreneurial vision on business challenges. He has been extremely successful in creating innovative products and guiding transformative and disruptive technologies from concept to reality. An interesting attribute about him is that he can merge a diverse, multicultural background with a passionate, lead-from-the-front approach to management, which has been a key driver in his ability to drive standout contributions from highly effective global teams. So we are proud to have you here. And those are our 4 distinguished jury members. And the one thing, if you see, that's common, and the one thing that we've been talking about is the amalgam of business and technology and the all-pervading role of data science, which pretty much is now making inroads into everything. And now, I'd like to invite on stage the man who kind of drilled this into us, this ethos. So to add some context to the data science journey at Shiv University, let's hear from a visionary and the man behind all these programs and initiatives. Dr. Bibek Banerjee is the Dean, School of Management and Entrepreneurship. He is also the Dean of the Academy of Continuing Education and the Director of University Strategy and Planning. He holds his PhD and MS degrees from Purdue University, USA, and a BSc Honors from Calcutta University. Dr. Banerjee has been a former professor of marketing at IIM Ahmedabad for over 2 decades. He has also had visiting professor positions at several international universities around the world, and he is an honorary director of the Academy of Indian Marketing. His research publications have appeared in several top-tier international academic journals and edited books. At IIM Ahmedabad, he created and led IIM Ahmedabad's successful collaboration with Duke University in the area of executive education. Over his career, Dr. Banerjee has designed and delivered numerous leadership programs for large global businesses across sectors all over the world. He has been the Director General and the academic mentor of the Institute of Management Technology Group, spread across Ghaziabad, Dubai, Nagpur, and Hyderabad. During his stint, he is credited for having led IMT Ghaziabad in becoming the 4th B School India to secure the coveted AACSB business accreditation. I'll now invite Dr. Banerjee to kindly join us on stage and show us his vision, and you will get a feeling of why he's a lucky charm for ACE and SME.
Delighted to see all of you this morning as sort of like a culmination of a thought process that, to be honest with you, has only recently begun with the institution of the Academy of Continuing Education that Rajat talked about. I'm going to take a few minutes, mostly to talk to the distinguished jury and, of course, the participants who I'm delighted to see in front of me. At the back row, I see my faculty colleagues. You know most of it, so if it's boring, try to pretend to stay awake and don't fall asleep. So first and foremost, a big welcome to you distinguished jury members and of course the participants. I do have some numbers to share with you as to what was the plan, what we have, what the 10 participants, these 10 folks have come from or come through, and then talk a little bit about the vision of what we are trying to build here in the university, Shiv Nadar University, especially in the context of as Rajat was saying, to build a center of excellence which is focused more towards the future than towards the past. Of course, in the process, not forgetting about the value of history, but really keeping the target to what the world is likely to become. Okay, so I believe there were about more than 1,000 registrations for this competition, about 250 odd submissions, and gone through several rounds, and now we are down to 10. So first, I'd like all of us to join me in giving a round of applause for you guys having made through a fairly tough competition. So we have 10 finalists, and people are coming from all over the country, which is great to see. And the prize money, of course, is only what we call a carrot, but the real romance is in the journey, right? So congratulations to all of you. Rajat has already made the introduction, so I talk a little bit about what we are trying to do here at Shiv Nadar University. As some of you might know, SNU this year we are going through our 10th year celebration. Okay, and in the context of university, which is starkly different from the context of corporate world, university brands way outlast corporate brands. Right? And I keep saying that if you think about organizations with an age of more than 100 years, corporate organizations, you will probably not even exhaust the 10 fingers in your two hands. But universities tend to have, especially the good ones, tend to have a very long journey, right? So we understand from Nalanda and Cambridge and Harvards of the world, they are like hundreds of years old, right? So in that context, we are a baby university, and we would like to turn that into our advantage. That we are obviously we are lucky enough not to try and repeat mistakes of the history. But I'm we are also, I know that the challenge is also to make mistakes, but the whole idea is to build a university which is really focused on excellence, and excellence that would be driven by research, excellence that would be driven by an interdisciplinary ethos, and excellence that is going to be driven by, a pedagogy which is like in the trifecta of knowledge, action, and behavior, okay? Or not just behavior, but an attitude. So we are trying to develop a university vision which takes a broader view of what people come to a university for, which is, overwhelmingly, I mean, at least in the popular sort of narrative, has been a little bit overridden by this concept of knowledge. Of course, knowledge is the bedrock, but then the issues around application of knowledge, issues around entrepreneurial, creating capital, creating value, and in that context, as Rajat mentioned, that we are trying to, by the way, in the 10-year history of the university, the business school is the youngest. So we currently have 4 schools in the university. So we have a school of engineering, we have a school of humanities and social sciences, we have a school of natural sciences, and we have the school of management and entrepreneurship. So as we are acutely conscious of the fact that we do not want to become another IIM or an XLRI, distinguished institutions where some of our paths have crossed in the past. And we are very acutely conscious that there is an E, which stands for entrepreneurship, as part of our business school. And what does that mean? What it means is that we are acutely conscious that, as opposed to the traditional model of post-Nehruvian professional education, which kept engineering, which kept medicine, and kept management away from the purview of universities and created these monolithic, standalone, autonomous institutions, we believe that we are a little too late for that model to succeed. But where we believe we are extremely excited to be at is that we are part of a university. And if you look at most of the top business schools or top engineering schools in the world, I don't think it's a matter of chance that they all happen to be part of an overarching umbrella of a university where you have different deep domains of expertise that feeder into or create an ecosystem of excellence. Okay? And the fact that the School of Management and Entrepreneurship is part of a university is, it does give us an opportunity to create a school, let us say, or an umbrella or an ecosystem where people who are not just job seekers, but they will be the tomorrow Shiv Nadars of the world, hopefully will come out of this institution. That's the vision that we are working towards. I wanted to share with you that we just went through, as part of us, like we looked at 10 years have gone by, the next 10 years. We were sort of doing some crystal ball gazing, and we went through a very deep exercise of our Vision 2030. And we identified 4 kind of themes on which the entire university has sort of pledged to work towards. And those 4 themes are cognition and behavior, okay? The second is energy. The third is environment. And the 4th is data, okay? And as Rajat alluded to today, data and analytics and sciences and machine learning, is going to inform and is also going to drive probably all other themes that we talked about. And in that context, we are, the Academy of Continuing Education, has been working on analytics as a very, very important, discipline and domain where we want to really co-invest with the industry and the young people of the country to really create some stellar value creation. So in that context, of course, the Analytics Olympiad was thought about to, we are aware that not too many people know Shiv Nadar University, and for right reasons, because we are not visible on television channels or newspapers through advertisements and so on. So we don't believe that we don't believe that university brands can be created like a Britannia biscuit or Coca-Cola. And we do believe that the work that we do here, if that's going to be fundamentally important, like Vivekananda had once said, that if you find a diamond somewhere, wherever you hide it, its jyoti is going to shine through. So I welcome all of you in that part, in a very early part of the journey. We do plan to build a significant practice-driven excellence in the field of data and analytics. I, of course, come from the business world, but as I just said, Nadar University. Also, I cannot brag about the fact that we have been accorded the Institution of Eminence.
It's
okay. We are the youngest ones to get it. One of the 4 private institutions in the country to get it. So our intent for excellence, has already got a stamp of approval. The hard work remains to be done. So delighted to see all of you in this room. This is the maiden venture, and I look forward to the presentations of all the participants who have come through. You have outrun a whole bunch of people, and once again, deeply thankful to the jury. Not only in this engagement, I was just telling Arun, who is the Associate Director of ACE, that hopefully this would be start of a journey of co-creation going forward. And we are happy to partner in any which way that would be obviously mutually fruitful and beneficial. So once again, welcome, and wish you a terrific day ahead. And for those jury members who didn't complete the entire ride of the campus, I'm sure my team will offer to give you a second chance so that you can complete your journey. So welcome again. Thank you very much.
Thank you, Dr. Banerjee. And he really nailed it with the vision and the impact and the value that we want to create through all of this. Obviously, these are windows of opportunity through which we try to showcase our belief and value, and we also get to hear from you. And now, with that conviction, I will invite all you young Turks to really battle it out on the digital turf today for the final round. And before that, I will just tell you a bit about the rules of engagement for today. So what will happen is that each of you will get to come on stage and make a presentation. The time allocated for each presentation is 15 minutes, right? And there'll be a timer that will pop up as soon as your time starts. And after 40 minutes, you'll get a warning saying that you just got 1 minute left, and you will try to kind of complete it within that 1 minute. And after the 15 minutes, your time will be up, followed by a 5 minutes FAQ session, right? And then that will conclude your piece, and then we'll move on to the submission from the next participant. So with that, we wish you all the best, and let's get started. So let me just introduce each participant one by one as they make their way up to the stage. So we'll start with Vivek Kumar, our first finalist. Vivek is a technical lead at the NatWest Group, and he has over 16 years of experience in the fields of enterprise application development, product engineering, technical architecture, machine learning, and AI. So he's already been there, done that, and I wish him the best. Please.
Good morning, everyone. And it's a great opportunity for Shiv Nadar University to provide me an opportunity to present my solution. So before we'll begin for the solution approach and what strategy I applied for this competition, I will just try to provide a brief background about the problem statement. So Machine Hack has organized this competition to predict the sales for all the items placed in a given outlet. And I think the main intention for putting this problem statement was pretty clear. Because nowadays, customers has lots of option to purchase different category from different megabart. And it would be very big investment for any company to spend so much amount in launching any outlet or any branch, right? So finding out the right set of features and understanding what would contribute to the profitability of that outlet, right? And using that machine learning will try to solve this problem. And I think the business objective is to understand what would contribute to the increase in the product sale, right? And what model tells about the data, how we can apply right set of practices for any given outlet so that it would make more profitable. So insight from the training and test data. So data contains close to 87,000 rows and which contains 12 different features. The other important insight is that train and test distribution have similar pattern in terms of distribution, except for the few fields like outlet ID, outlet size, and outlet location type. Apart from that, all the features follow similar distribution. But we have seen some variation for the item type per outlet, right, which has slight deviation in train and test data as per the data analysis. The cells, which is the target column, is mainly right skewed, and we have seen some negative value also. So close to 0.5%, we have negative cells. The next two findings, which is mainly around the old outlet, has a positive relationship with target, and this is based on this analysis. And we can clearly see from this chart that all the outlets which are opened between 1996 and 2004 contributes to more sale, right? So if you look this diagram, we have this distribution, and it clearly shows that all the outlets which are old has built a good relationship with customer, and they have very good brand in terms of how they sell their products. And that's why we have seen a lot of sales which falls under 8 to 10,000 range, right? So it's a clear pattern from the data. And we can see that all the outlets which are open before 1996, it has very less evidence around selling product which falls under 8 to 10,000 range. And similarly for all the new outlets, we have seen very less evidences. So that was the first evidence. The second evidence, which we can clearly see from the data, that all the low food items which are sold in supermarket type 1, which is the top one, are more popular among customers and has a positive relationship with the outcome, target outcome, which is sales. Right? So these are the two main insights which I could draw from the data. And after the model result, we'll see how the outcome of model results correlate with these data, right? It's not moving. It's not moving. This one, oh, sorry. Oh, yeah, sorry, thank you. So before doing modeling activity, I have done a small data pre-processing just to clean up the data. So the first thing what I did, I converted all the categorical data to numeric. And then I performed a small data cleaning activity for the food content type, because data contains a lot of different values for the same item, right? So low fat and regular, right? So I have done a small cleaning activity to align the values, okay? And third, I have converted the outlet year, which was defined as a numeric value. I have converted this to categorical data type, right? So these are the three pre-processing I have done. Then after that, I started doing data preparation, right? And the data preparation consists of two different set of features. So the first feature which I have built was mainly around the item weight and item MRP, right? Because based on data analysis, I have seen that it has some positive relationship with the outcome, which was sales for the product item. And using these two fields, I tried to derive some additional fields. So like I calculated the ratio between item price and item MRP, right? And the second feature which I have extracted, I have taken the integer and decimal part from both these item price and item MRP, and which was one of the core feature for this overall data modeling exercise, and which contributed to increase in the performance of the model. The second set of features which I have derived based on topic modeling, and what I have used as a part of that, I have taken outlet ID and item type and try to find a pattern that what type of items outlet should sell so that it would make them more profitable, right? So I have used these features and feed these data to my model, right? So these are the main data preparation I have done for this work. From the model building perspective, I explore different models like light GBM, XGBoost, random forest, linear regression, right? But what I found that CatBoost model was much more effective for this problem statement. And it's mainly due to the fact that this data contains 7 different categorical features, and CatBoost really works very well with respect to categorical features. And the other benefit which I have seen for this CatBoost model, that it has very effective mechanism for handling all the categorical features, right? It provides all those functionality out of the box, right? And the other benefit also was that the standard parameters which CatBoost model use, it works really well, and we normally don't need to do a lot of hyperparameter optimization, right? So these are the main factors why I have chosen CatBoost model as a final model for my training and evaluation activity. Model evaluation and test prediction. So for model evaluation, I have used cross-validation, right? 5-fold cross-validation I have used for model evaluation. And the test predictions are generated for each fold, and finally it has been averaged out to generate the final test prediction, right? So this was my strategy for model evaluation and test preparation. And the CatBoost model is very fast because this data set was very small, so it will not see much differences in terms of training and prediction time, but for the larger data set, it really works very well, right? So again, if you think about the deployment of this model, then it will really work very well. Once we'll have a very large amount of data, and the training and evaluation and the prediction would be really very fast. So these are the model test results, right? So if you look the model test result, it clearly shows that the outlet year was one of the dominant predictor for predicting the sales of a given item, and which can clearly see from the right hand side of the graph, right? Outlet year, and we have seen red color, which will indicate that if we'll have the outlet year, which will have a more positive impact. And also from the left side, we can clearly see that the outlet year 1996, 1998, and 2003. And we can clearly see that these are the high predicted value. And this clearly maps back to our data analysis part, that all the outlets which are opened in past, mainly between 1996 and 2005, are more trusted among the customer, and the model also suggests that the same is true. And from the left side, you can also see that the outlet type supermarket 2, it's a negative sign from the chart, which means that supermarket type 1 is more profitable from the sales perspective, right? The other thing you can also see from the right side of the graph, that item food content, right? So item food content is again another very good predictor, that customer normally prefer a low fatty food or fatty goods for consumption, right? And that's what we can also see from the chart. The other, you can see from here, item food content regular, which is a negative direction, which means that the low fat content is more popular among the customer. This provides, right? The other important feature which we can see, that the new feature which I have derived based on topic modeling, we can see that item type 2, it's on the high side, which means the whatever feature engineering I have done for predicting this L, it has good impact on the model performance. And this chart also clearly shows that it has a positive relationship with my sales, right? The other thing which we can also see from this chart, item visibility, which is at the top side, which means that the items which are more visible would have positive impact, right? So we can see it from here. Yeah, I mean, these are the model results, and that's what I have explained here from result explanation perspective. The business recommendation, right? So based on model results and based on my data analysis, we can say that business can focus on improving customer trust and service for the new outlet branches, because there we have seen that for the new outlets, there is a scope of improvement, and probably we can attract more customers if we'll provide a proper customer service and trust, and if business would be able to build customer trust. The second outcome, which is around business can focus on opening outlet on tier 2 city, and this again ties back to model result explanation. The third outcome, business can focus on opening supermarket in type 1 outlet, right? The business can focus selling more on low fat goods, because it generates more selling. And also business can focus on optimizing the placement of the items which are more visible. Yeah, I think I'm done from my side. Yeah, I mean, that's it from my side.
So thank you. So thank you, Vivek, for the presentation, and sorry your time was up. But we will now follow this with the
Sure.
FAQ round. So I'm sure the jury and faculty and some of us have some questions.
Yeah, sure.
And let's see if we've got 5 minutes for that.
Sure. Yeah, Judy.
If you could just take the...
So it was a great presentation. So, and congratulations for coming to this stage.
Thanks.
So my question is, like, you chose the CatBoost model. Which other models did you try and why you found this to be the best? You mentioned it briefly why you found it to be the best, but which other models did you try?
I tried Random Forest, I tried Light GBM, I tried XGBoost, right? I tried the linear model also, but what I found that the gradient boosting model works best for this problem statement, and within boosting model, the CatBoost model worked really well because, yeah.
So how is the CatBoost model different?
CatBoost model, it's another type of boosting algorithm, but the main benefit of using CatBoost model is its functionality to support the categorical features, because it do lot of different type of feature engineering, because normally for the other boosting model, we need to manually generate the features like mean target encoding, and it has other features like interaction of the categorical features, right, which CatBoost model automatically do out of the box. I mean, that's the benefit of using CatBoost model. And while exploring the model, I found that this additional feature has boosted my performance, the model performance.
Great. And there was this variable item W float. What was that?
Which one?
I think it was item underscore W underscore float.
Yeah.
What was that variable?
It was taking the integer and float part of the features. I segregated the integer part and the decimal part in different values, different features.
Okay.
Yeah.
Vivek, hi, Anish here. Good presentation. I have a question with regard to scalability of this entire analysis and project. If my memory serves me right, and basis what I have learned from my experience, CatBoost model is also very much applicable from a recommendation engine standpoint, where you can build a recommendation engine and basis the trend of the users, an item or a user based, it can pass on generate a recommendation. If you were to look at scalability and a future use of this specific model or this specific analysis, primarily from a banking standpoint, is there anything that you think can be done where we can potentially design a recommendation engine for a banking customer?
You mean how we can use this model result, right? Or you're looking for the other alternatives?
Both model results as well as, and in addition to what more can be done to scale this idea. So let's say if we were to commercialize this idea and scale this for a wider use, what changes do we need to make it more acceptable or tune it from a financial services standpoint?
Yeah, I mean, from the financial industry perspective, I think the main focus would be around how well we would be able to explain the model results, right? Because here I have used the Sharp model interpretation package, right? So from the industry, mainly from the financial industry perspective, the model results should be clearly explainable to all the stakeholders, right? And also it will depend upon the different type of queries all the stakeholder will ask, right? So here I have used a single interpretation technique, right? But depending upon what type of queries or concerns we have within the organization, we can adopt different technique like partial dependency plot or anchor model interpretability technique, right? So yeah, we can probably work on those directions to make it more accessible to all the business stakeholders, and they would be able to appreciate why model is behaving in this manner.
Okay, thank you.
So just one question. So the business outcome that you talked about at the end, right? So there were 5 or 6 points.
Yeah.
If you were to focus on the top 2, because if I'm heading a company, right, it's very difficult for me to look at all the different options.
Yeah.
Where would you put your finger on based on your model?
Yes, so based on my model, I think the selling of low-fat food was one, and the first one was the improving customer trust and support, mainly around the new outlets, right? Because there we need to focus on, right? Because whatever we have seen, it's based on the past data, right? But now we need to think in future, right? What we can do to generate more sales for the new outlets, right? And as per the analysis, we have clearly seen that it's not very well for the recent outlet, right? So we can save business to work in those directions, right? So that more customer will attract toward the new outlet branches, and yeah, we can add more items in those outlets. Yeah.
Thank you. Thank you. Thanks for the answers.
One
So with
last
this, we'll have
question,
to.
One last question.
You do?
Okay.
Yeah.
All right.
Following up on the previous question with regards to the business outcomes, I think there are a lot of assumptions on the proposal to the business. See, we're talking about supermarts that were operating, that started before 96 and beyond 2004, and we said that they were not very, the sales out there was not very profitable, right? And then we say that the business should focus on spending more time on the newly opened stores. But there could be a pattern as to something went wrong before 96, and that similar thing is repeating now with regards to the ecosystem, not just looking at the sales data, number one. So I think that is something that might need to be worked upon from a business standpoint.
Yeah, yeah.
The second thing, we say more sales is proportional to more profit, which might not be true, right? Because your sales are your top line, and then that does not naturally culminate towards more profit. So where is that gap? That also needs to be looked at from the data.
Right.
So I think that is something that should be added in your
Yeah,
business
yeah,
recommendations.
yeah, yeah. Thanks for that. Yeah, that's a good point. Thank you. So
Okay. So thanks.
yeah, thank you very much. Thank you.
Thanks, Vivek. And now I would like to invite the next finalist for today, and that is Akash Gupta. Akash is a data scientist at HSBC, and in the past has worked with TCS and has been an ambassador for the World Blockchain Hackathons. So he's really been into this, and we hope to get a very interesting submission from him. So, Akash, the stage is yours. Akash is just taking that extra time mentally rehearsing his script, just getting a little extra advantage while his mic is taking some time to get plugged on. Are you good to go? All right, all the best.
Audible? Yeah. Hi everyone. Good morning. I am Akash Gupta, and currently I work as a data scientist at HSBC, EDPI, Electronic Data Processing. And recently I graduated in 2020. I completed my graduation in 2020 from AKG. Yeah. Now today I am presenting Analytics Olympiad 2021, and this is organized by the Shiv Nadar University and partnership with Machine Hack. This is the platform of hackathon. And I have won 45 plus machine learning hackathon till my college. Yeah. Yeah. Now, the problem statement is that based on the Mega Mart. This the data belong from the Mega Mart, and data basically two category. One is the item category, and second was the outlet category. And the target variable is sales data. And the first time the given data set is hide 3 columns, like item. Sorry. item FC and item visibility and outlet type. That's are hidden in the hackathon time, and in the bench time, that's are given for the testing purpose, our scores, like private score and public score. And in the train data, that's are given like 87,000 row, and in the test data, like given 37,000 row. That's approx 42% of data, like for the testing. And I use some statistics, and I find out the mean value standing of the sales data 1911, and the standard deviation goes from 1 to 91. This means the high frequency of the sales data is lie between 1200 to 2000. That's based on the analysis of data. And in the sales data, there are 397 rows have a negative value. That is the impact as an outlier for our model. But when I remove that features in the data processing, in the data pre-processing, then the score will be go down. So I put in my final model. And the second things, like I found out the mean, count, standard, minimum, and as the box plot, like 25% data, quartile 1, and 50% for the quartile 2, and 75% for the quartile 3, and that are given data set. Like the item weight is, have a mean value like 14 kg, like parameter is not given, but I think if we conclude as a kg, then 14 kg. And item visibility is 0.04%, and item MRP is 150, and outlet year is like 1919, and sales is 1911. And yeah, for the first I like in that item ID and outlet ID have alphanumeric types. So for the data in the data pre-processing, we exclude as a number, like someone have a mountain the ID like A1, A2, that is the ID types. But sometimes the ID have a hidden, based on like we are checking in the data understanding point of view, we are checking like there are some leak function or not. But I found there are no leakage. But if I put item ID in my final model, then score will be good, but private leaderboard goes to the bad. So item ID and outlet ID we need to remove in the final model, because this is only ID, this is not a features. And we draw the skewness and weight of evidence and information value. That weight of evidence and information value that used in the credit card and other risk analyst, other risk factor. So this is the one major fact to how to get like which one is the features have a more impacted on our data. This is the information value, and the weight of evidence is directly related with the target variable. Which features is dependent, which features is more weightage on particular sales price prediction. This is the weight of evidence, and this is the feature skewness. And I found out the data are skewed or not. But I found data are not more skewed. Only item viscosity is skewed, right skewed, because it is a positive value, and 60%, 0.60, and 60% is like a data tend to the right side, and sales is a target variable, so we can remove from the model because we are just predicting. So only item weight and item visibility and item MRP and outlet year. That's are the skewed value I completed because it's the continuous variable. And for the continuous, like I got item viscosity is the right skewed, and outlet year is the left skewed. Is the positive and negative. So this is all analysis I used in the data pre-processing part. Yeah, data preparation, and in that we are doing data pre-processing and all those stuff for building the final models. And first I combine the both data, train and train, and make a one data, because we cannot do more operation on different on train and test data. So I combine whole data, and I check the missing value, but the data is not have a missing value. Data is completely not more dynamic data, so no have any missing value. And for outliers, I check the box plot graph, and I find out like 5,000 value of sales, because sales feature have a mean value is 2,000. And I have removed outliers as per model requirement, but I built 3 or 4 models, but I found there are no remove out, because outliers in available only sales data and the sales target variable, so I can't remove. And the static technique, and I make more 50+ new features, based on aggregation, based on group by, based on statics like mean, median, count, sum, and solve. So aggregation is given me high score, like from the 1270 RMSE to directly 1260. So I used aggregation with the item weight, item MRP, and other things. And also, as per time to time, I check my cross-validation score with our weight graph. That's given if our CV score is like 90, and in the leaderboard, that's also showing as a 90. So that means my model is like not so tending, not so dynamic. So it's work properly. So I will check using the cross-validation score, and I have not tried binning because I use directly aggregation function. And I use dummy function for the categorical variable, because the categorical variable we can solve by the two things. First things we can using the level encoder, otherwise we can using the as a dummy. So we can use the dummy, like if category features like item types like ABC, then it's make a new features, new column ABC, and 0, 1 values as like a binary function. That is I use dummy function is that because it is some fast, because the value is 0, 1. And model works better in that. And I used aggregation with item weight and item MRP for the continuous features. And for the outlet category, we find out like outlet location type and item type. And next slide. Yeah. For the model building purpose, I have used different boosting algorithm like XGBoost, CatBoost, LightGBM. But in my final model, I used LightGBM because it's performed best. And in LightGBM, I used parameter, hypertuning, and different because I have something good in LightGBM model because I open the parameter and change the boosting type. Like in LightGBM, there are 4 boosting type. GBDT, this is a gradient-based optimizer boosting, gradient boosting decision tree. Second one is the RF, random forest. Third one is the DIRT, and fourth one is the Gauss. But in my case, GBDT is performed best, so I put in my GBDT in my final model. And I use the random state 42 because this is the 42 data is selected for the validation purpose. And first I draw the data as like 90% for the training purpose and 10% for the validation purpose. But in final model, I used 80-20. And I use the L2 root parameter for the improve the accuracy for my LightGBM. I used also bagging frequency and bagging seed because in the decision tree and the random forest, bagging and boosting perform well. So for the boosting type, I used GBDT, that is also gradient boosting type. But for the decision tree, like GBDT is combined, so I use bagging frequency and bagging seed and set the frequency as per model tending. And after the training model, I draw the features weight. And this is the features weight. This is the index level features. In that outlet ID 2 is performed well. This is the one index value of the sales data 1940. And overall features impact in that graph is so dirty. But this is like outlet ID, item MRP, and all those stuff is all those things are available. In that, the blue means the cool type. The data is not more trending, data is not more dynamic. But in the red part, data is some dynamic for that cases, that parameters basis. So this is the Shapley based, Shapley adaptive based graph. Yeah, and this is my model building evaluation. After the building my model, I plot that graph, which is the high parameter impact our model. So I got AGY and AGX. This feature I built from my name. So AGX and AGY, that is the item MRP I divide by the item weight. Like if item MRP is like 2000, and in that data set, there are many things like quantity of data and other things. So as per like item MRP and item weight, we divide it and make a two features, AGX and AGY. And these are the top features. In my top features, there are the AGY and standard deviation for the whole model, and item IDM and AGX and item viscosity and mean of the whole data. This is the top features in my model. And I using for the testing data, I using the K-fold cross validation and using the 10 iteration means 10 epochs. By this way, I got third rank in the public leaderboard. And also, I have not performed in the ensemble technique due to less number of submission restrict in the 3 submission in the machine act. So I used different algorithm because one day only 3 submission limited. So I do, but I cannot perform ensemble technique. So, and the LightGBM alone performed well in my case. Yeah, and result and recommendation, my public result is 1259 and my private is 1260. But when I bench data run, I got 1258 RMSC value. This is the good, and I got second rank in the private leaderboard. And for the, you have used like a Find My Funnel by, I tried CAT Boost, XG Boost, but I have not much hyperparameter tuning and tuning in the that both algorithm. And so I have more used in the light GVM. So light GVM is the one way to choose my model. And also this light GVM is used because it's easy to use creating API for the using like next day, if like any end user want to predict the data only putting something, then we using the Flask and Django and make a web type apps and other type apps. Also light GVM is more compatible because it's used with the CPU and GPU, only some parameter is passed, so it's work better with the CPU and GPU. But I use only CPU because data is less. If data is large, so I can use GPU. And light GVM is so fast, so in my final model, light GVM, I choose light GVM. And recommendation based on the SAP score. This is all score is combined in that way, like outlet year and outlet ID and outlet type and outlet FC. That's our high impact on the model. Because SAPly is only do like this is my model and this is the black box model. But model have a which parameter impacted. So this is SAPly, this is draw the graph very accurately, and SAPly is a game theory technique. So everyone used in the hackathon, because this is the one trick to win the hackathon and one trick to improve the accuracy and found the parameter. So I count like the outlet year and latest year impact more that because in that like if you say SAP value impact on model output, the 0 is like a model value. Yeah, so 0 is a like a impact our model, and this like 200, this the negative side is more than, like outlet type is red and this is negative value, but our model better perform because this is only the model based graph. And I recommended that like based on my analysis and my model, because in their data set have a limited number of features available. But in future, if I use that data for the business model, for the business outcomes, then for the business outcomes, like we define the category, like bucket category, 10 category defined, and each category have a different price sectors, have bucketization. So after that, we can conclude to the cells as per bucketization, like which bucket is an improved cell, which bucket is the negative cell. So after that, we can put up only negative buckets and find out the weightage from this graph. So by this way, we can use like as a business model, and item weight and item MRP perform well.
So Akash, your time is up.
Yes, sir, 55 minutes.
Yeah, no, time is up. Its time is up. Yeah.
Okay, sir.
So now over to the jury.
Yeah, thank you.
And yeah. So jury, if you have any questions for Akash.
Akash, nicely presented. Especially, I like that you touched upon the deployment section also a bit,
Yeah.
And how it could be integrated. Now, you did mention that you created 50 plus new features, and in your presentation, you've spoken about 2 of them,
No.
AGX and
Yeah.
AGY.
Yeah.
What were some of the other features? And
Some of the other features are based on the aggregation.
Okay.
Aggregation is a type of like a group by aggregation with the item weight. Like if an item weight and find out the count of outlet year, like which year impacted. So this is the I creating the features based on the like item weight and item MRP. In that case, there are subset of 5 category: outlet category, item category, all the categorical type. And for the categorical, I build the features count and sum. And for the continuous, we find the mean, median, standard deviation, 25% data, 50% data, 75% data. That's all the 6 features. And 6 features other with item MRP, 6 is 12 features. And after that, for the base data, item viscosity is the also continuous variable. So I use the group by 18 features extra more. I building 2 features extra and 10 features given. So combining features 50 plus.
all right, that answers.
Akash,
Yeah.
well presented.
Yeah.
Okay, I'll begin with your intro.
Yeah.
You said you have won 45 hackathons.
No, I participated 100 plus hackathon, but I won 45 plus, 45 plus hackathon.
Okay, so you've been participating from your college days?
Third year from college.
Okay, okay. I
Yeah, I
think it would be
participated in
inspiring.
second year, but I am starting my winning journey from the third year.
Okay.
Yeah.
Okay, great. So just very small question. That variable item underscore viz, what is that variable?
I can't understand. Item?
You had one of the variables as item underscore viz, VIS.
Item weight.
No, VIS.
Item visibilities.
Visibility.
Yeah.
Yeah. I wanted because I heard it viscosity every time. So I was a little confused. Okay.
Yeah.
Thank you.
I think my only question again going back to the business recommendation. Right?
Business recommendations are that like the sales data, I predict only price predicting for the item ID. Like I predicting the sales like particular row wise, but we cannot use the group by. For the business outcome model, like if we get divide the like I predicting 37,000 row, if we divide in 10 category, like 37 divided by the 10 category based on weight of evaluation. Information value that's are given like which impacted features more, like outlet year impacted more in some cases, but item weight is performed well for other cases. So if we define 10 bucket as a bucketization of prediction, our prediction, so we can decide like which sales team more perform or which category have impacted on that. So if I use bucketization in the sales data, so this is our analysis because every 10 participants have 10 other analysis. But as per my analysis, if bucketization of MRPs, like 3700 only have a one bucket and second 37 have a one bucket, and every bucket have a different value impacted because every other features. So after the bucketization, we can draw a mean value for the score. Which value is the like we got profit? Which one is not profit? Which one is not profit? Why? Because 37 data, 37,000 row, this is hard to get. But for that one bucket, we need to find easy. So this is our business model. We can improve ourselves. And this weight of evidence and information value are used in credit risk analysis and other things. So this is the best technique to use because credit analysis score is dynamic. Is like positive value is like negative value. So I found the exact deviation very accurately and very easily. So this is your.
Thank you.
Yeah,
Thank you, Akash.
Any other questions? Thank you.
Okay. Thank you so much, Akash. And now we have one more presentation before we break for some warm beverages. So we have Arpita Sagar next. Arpita is an MBA student from Delhi University, and she's an aspiring doctoral candidate whose research interests lie primarily in the field of health, data science, and XAI. She has worked on research projects in biomarker discovery for breast cancer stratification and identification of COVID-19 in chest X-rays. So I mean, a topic that's obviously very close to all of us, a very, very pressing and important topic. So, Arpita, wish you the best. And one more thing to all the participation, the finalists, is that you can see your presentation on the screen displayed here. So if that's more convenient. And the timer is set for 20 minutes, which includes 15 minutes of your talk time, followed by 5 minutes of the FAQ session, right? So over to Arpita. Are you good to go? Yeah, please. Come.
Hello. 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 Yeah, is it working? Yeah. Okay. Hi. Hello, everyone. Good morning. My name is Arpita. I'm an MCA. I'm an MCA student at the University of Delhi. And firstly, I'd like to thank Shiv Nadar University for giving me this opportunity to present here. And I'll just start. So basically, an overview of the data set is that it is sales data from mega marts. And it includes a variety of features about both items that are being sold there as well as the outlets at which they're being sold. and approximately 80,000 instances in the training set and 30,000 in the test set, along with 12 features, of which one is the output, which is the sales target. So this is just basically an overview of the data attributes that are present along with the data types, the type of data which is there. So for items, you have different attributes like ID, what is the weight, type of the item, fat content, visibility. And for outlets, further you have attributes such as the year in which it was established, what is the location type of that outlet, and so on, along with the data types, which is the programming data types which are there. So in this particular case, the sales data that is there, it is skewed, but I haven't performed any outlier removal or done any oversampling or undersampling, because here the skewed nature of data might be important, because skewed instances could be either a very high sales, which is during at the times of sale or something like that, and then next is just an overview of the number of unique values that are present for each of the variables. So this, as you can see, is the distribution for the target variable, which is sales, which is highest number of sales are around 2,000. So this is again just a distribution of the various other variables that are there in the data set, just to say, check whether or not there are any anomalies or something. And other than that, no null values are present in the data set that has been provided. So next, coming to data preparation, because there are no null values, there's no need for any imputation strategy. And again, as I've already mentioned, outlier removal or any undersampling or oversampling strategies have not been applied. Coming to the features, there's no obvious arithmetic or logical relationships between them, so I haven't derived any new columns or features for this data set. Initially, I'm using, so there are 12 total features, out of which 1 is the target, and 11 are being used to predict that target. So initially, I've taken all of this 11 features, and I've used something called permutation importance as a feature selection method. So that essentially, that is done once my model has been fit, and it evaluates how randomly shuffling a particular feature affects model performance, keeping all the other features constant. So I've used that as a feature selection strategy. No binning has been performed for any of the continuous valued features. For numerical columns, I'm scaling them down to 0 to 1, because I've used one-hot encoding for categorical columns. So just to ensure that all of the features lie within the same value, which is 0 to 1. So, additionally, to evaluate my model, I'm using 10-fold cross-validation. So data has been split into 10 consecutive folds, and each fold is then used as 90% of the training data is used for testing, and 10% is used for, 90% is used for training, and 10% is used for testing. So again, because boosting methods tend to always outperform other simpler methods, I've only tried boosting models here. The ones that I've tried are LGBM, XGB, and CAT boost. And I've also tried a voting regressor, which is essentially an average of the 3 models. And what I found out was that CAT boost regressor gives me the lowest RMSE over 10 folds. And that is the one that I have finally used to build my model. So hyperparameter tuning, the only hyperparameters that are not set at default values is the number of iterations that I've set and learning rate. And along with that, like I said, initially I've used all of the 11 features, but then I'm calculating permutation importances for each of the features, and then removing one feature at a time in an iterative manner. So the feature with the lowest permutation importance has been removed. So in that way, I've removed 3 features, which are item weight, item visibility, and item ID, which were lowest in subsequent iterations, and I kept removing until the error stopped reducing. So finally, for my final model building, I've used 8 features and trained it on the entire set. So coming to the results, the average RMSE over 12 folds is around 1273, slightly less than that. and along with that, the RMSE for each of the folds. Along with that, final RMSE for the entire training set, because the model is fit on the entire training set, as well as the RMSE for the test set, which is from the machine hack platform, where the model and the submissions were made. So coming to model insights, obviously I've used permutation importance that is used on a fit model itself. So from this itself, this is for the final 8 columns that I have used in as features for the model. So from this, generally seeing a trend here is that outlet, so all the 3 features that I eliminated using this were all item-based attributes. So we can say that outlet-based attributes tend to contribute more towards the model performance and towards accurately predicting the sales as compared to item-based attributes. So they're more, which would suggest that sales are more reliant on the outlets themselves rather than on what is the inventory there. So for the data collection should focus on perhaps more outlet-based attributes such as user experience or outlet locality or ease of access, what the user experience is at the outlet. And based on this, the observation is that outlet year is the most relevant feature, while item MRP is the least relevant. And this is just based on permutation importance. Right, now coming to business insights and recommendations. So for this, I've used an XAI, explainable AI-based strategy, and I've also used Shapely additive explanations, SHAP, which essentially show how a feature affects model performance, because permutation importance only says that this feature is more important than some other feature, but how exactly those values contribute is through SHAP. So here, what I have is a global feature importance plot. So here, also to see is that initially, in my final model, I have 8 attributes, but here the feature space has been modified. So the variables starting with num are the numeric variables, and the variables starting with cat are the categorical variables, because they've been transformed using one-hot encoding. So categorical variables are higher value, essentially means 1, which means this category exists or is present, whereas 0, lower value is 0, which means that this particular category does not exist. So from this, I can see that obviously outlet year is the most important feature for the model, and additionally, I can draw other insights as well, such as whether or not an item is a soft drink is a stronger indicator for predicting sales as compared to whether an item is perhaps meat or seafood, which are much lower in the model. Or additionally, which outlet is the most important for predicting sales. So based on this, I can see that outlet 18, which is in the 3rd position, is the most important. So this is again similar to permutation values which were being displayed, but because it shows the overall contribution. But if I want to get to how different values are contributing to model performance, that is through something called a B-swarm plot. So here the sort of outline is that on the x-axis, I have how model performance is being impacted by a certain value, and all of the features, all of the instances in the my set, my data are displayed as points here on this graph, and on the left I have the features. So higher value of a feature is represented using pink, and lower value of a feature is represented using blue. So and purple essentially shows me a sort of mix of both higher and lower values, which are not essentially very separable. And right. So here I've just highlighted a few examples. Again, this what exactly the sort of financial decisions would depend on. So for instance, in the first case, outlet year, here we can see that while there is not an exact separation, we can see that the lower values at the top corresponding to number 1, the lower values for outlet year, which would mean less recent outlets that have been established less recently tend to have a negative, tend to lower my predictions or cause lower sales. Whereas the pink portion shows that those are higher values, so newer outlets, they are contributing more towards the sale. So that can be used as a this information can be used to sort of decide which outlets I should upgrade or which outlets should I close, or when or if new outlets are being opened, which outlet should they be modeled on. And secondly, something like, so second point is like fairly obvious, because I would expect that lower products with lower MRP would cause lower sales, and products with higher MRPs would cause higher sales. And thirdly, we can see that, so categorical items here, so in the third point, regular items with regular fat content tend to cause lower sales, while products with low fat content tend to sell more. So this can again be used based on whether I'm trying to optimize either my inventory or my outlets, depending on what my objective is financially. These insights can be used to drive business decisions. That's it. Thank you.
Well, out of time, so we have some more time that the jury can spend in, evaluating your submission. And over to the jury. Please fire your questions.
Arpita, hi Anish. Very well presented. Excellent clarity of thought and the message. I have one question with regards to the outlook year, which seems to be driving the entire analysis. Now, from a very much principle of an element of bias that a machine learning algorithm can induce into the overall analysis, do you think if you were to knock out outlook year, the outlet year from your analysis, will there be a different outcome?
As in, are you talking, will it increase the error?
Yep.
Yeah, it would, because that was the most important.
So one is increasing the error. Second is completely discounting this specific metric. So let's say you completely take out the outlet year from your analysis. Was this done? Did you test it? If yes, what was the impact on the overall outcome?
I haven't tested it as well, but permutation importance that I've calculated, that is essentially that if I'm randomly shuffling, so permutation importance score was also highest for outlet year attribute, and that essentially is an indication that if I'm randomly shuffling outlet year, basically creating a sort of very random set of values, how will that impact model performance? So because it has the highest value, it shows that this is the most important to my model. So if I do remove it, it will cause larger.
And I completely agree, and this is where the challenge lies, because statistically, if your analysis is indicating that a particular metric has biggest influence on your model, it should also be tested that what happens if you exclude that most influential metric, will there be a different outcome? But that's fine, that's more of a feedback.
Okay,
Thank you.
I haven't tested it right now, but it would, in all likelihood, increase the error.
Okay, thank you.
Very well presented. Just one question on, there is a plot with the sharp value where, you said the outlet is more important and item-related features become less important, right?
Yeah.
But if I look at that graph, top 6, 3 of them are item-related and 3 of them are outlet-related.
So that was obviously, so that is because I've used one-hot encoding. So item attributes such as if I have item type, so all of the different types, they are transformed to a binary 0-1 attribute as well. And that was also based on the fact because I'm not using all of the features. I've removed 3 of the features, which were item MRP, item visibility, and item weight. So all of those are item-based features, which feature selection I did based on permutation importance scores. So that is also because I said, because all of the features that are removed and considered least important in the model are item-based. So that was generically based on both SHAP as well as permutation importance scores.
Okay, all right.
Any more questions? Okay, thank you.
Okay, thanks. Thank you so much, Arpita. Thanks, jury. And now we will break for around 10 minutes for some warm beverages. I believe they're already ready at hall number 2. So, and after that, we'll resume with the next few. And I would say we take around 4 more presentations before breaking for lunch.
The unique value proposition of the School of Management and Entrepreneurship at Shiv Nadar University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment, which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs so that our students emerge as theoretically grounded, practical problem solvers for the digital world. Shiv Nadar University is a comprehensive, research-focused, student-centric university that is focused on student outcomes. And the School of Management and Entrepreneurship sits smack in the middle of that ecosystem. In machine learning, there is a concept of meta-learning, which basically means learning to learn. Much of our educational philosophy at the School of Management and Entrepreneurship at the Shiv Nadar University is to attempt to create a meta-learner among our graduates. There are two aspects of education we believe that is going to drive the future. One part of that education is going to be changing over time, such as tools, such as techniques. With the pace at which the digital economy is evolving, the rate of obsolescence of those tools and techniques is very, very fast. There are certain unchanging aspects of education, which is deeply rooted in the theories and the fundamentals and the first principles that are relatively unchanging. So this balance between the unchanging and the changing aspects of education is very much a guiding force of most of our programs at the School of Management and Entrepreneurship. And the blend is largely geared towards creating a student outcome wherein they become lifelong learners and they figure out how to navigate the environment to how to stay relevant and ahead of the curve as the most uncertain future unfolds. The COVID has changed the world fundamentally. The old models of education based upon rote learning, based upon use cases, based upon examination is now defunct. There is wide-ranging agreement that education needs to be re-examined, needs to be reimagined to create a leadership that would drive the future economy, which is going to be heavily driven by digital technology. So in our school, what I am attempting to do is to reimagine, reboot that curriculum and the model of business education, wherein this whole aspect of entrepreneurial trait with a clear focus on the digital technology takes the center stage of everything that students do here at the School of Management on Entrepreneurship. So at the School of Management on Entrepreneurship, we will be working with people who are invested in becoming leaders of the digital economy. The unique value proposition of the School of Management and Entrepreneurship at Shiv Nadar University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment, which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs so that our students emerge as theoretically grounded, practical problem solvers for the digital world. Shiv Nadar University is a comprehensive, research-focused, student-centric university that is focused on student outcomes. And the School of Management and Entrepreneurship sits smack in the middle of that ecosystem. In machine learning, there is a concept of meta-learning, which basically means learning to learn. Much of our educational philosophy at the School of Management and Entrepreneurship at the Shiv Nadar University is to attempt to create a meta-learner among our graduates. There are two aspects of education we believe that is going to drive the future. One part of that education is going to be changing over time, such as tools, such as techniques. With the pace at which the digital economy is evolving, the rate of obsolescence of those tools and techniques is very, very fast. There are certain unchanging aspects of education, which is deeply rooted in the theories and the fundamentals and the first principles that are relatively unchanging. So this balance between the unchanging and the changing aspects of education is very much a guiding force of most of our programs at the School of Management and Entrepreneurship. And the blend is largely geared towards creating a student outcome wherein they become lifelong learners and they figure out how to navigate the environment to how to stay relevant and ahead of the curve as the most uncertain future unfolds. The COVID has changed the world fundamentally. The old models of education based upon rote learning, based upon use cases, based upon examination is now defunct. There is wide-ranging agreement that education needs to be re-examined, needs to be reimagined to create a leadership that would drive the future economy, which is going to be heavily driven by digital technology. So in our school, what I am attempting to do is to reimagine, reboot that curriculum and the model of business education, wherein this whole aspect of entrepreneurial trait with a clear focus on the digital technology takes the center stage of everything that students do here at the School of Management and Entrepreneurship. So at the School of Management and Entrepreneurship, we will be working with people who are invested in becoming leaders of the digital economy.
So we'll resume in another couple of minutes. And I'll request everybody to take their seats. And so once again, I'll tell all the finalists that, you have overall 20 minute slot, out of which 15 minutes is the time that you get to present, and followed by 5 minutes of question handling that you face from the jury. And I will also ask you to kind of make advantage of the screen here so that, you'll be able to look at the audience and the jury and through the presentation. All of that you see on the screen behind you also gets projected here. And I'll also request the next participant to, get ready, get their audio enabled for the presentation. The next participant is Rahul. Rahul, you ready with the mic set? Okay. We're just waiting for a jury member. And while we wait, I hope that most of you were able to connect with and take away the points and the presentations that were being shared by the finalists. They've obviously put a lot of thought into it, and you never know what may come from such platforms, because the best ideas sometimes can come out in strange ways, can be co-created, and it may actually lead to things that you implement and will lead to bigger things than what we foresee at the outset. So, well job done for all of you. And we'll just begin with Rahul in a minute or two. We're just waiting for a jury member to join us. You can see behind me the MB Online video playing.
Of the School of Management and Entrepreneurship at Shiv Nadar University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment, which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs so that our students emerge as theoretically grounded, practical problem solvers for the digital world.
That is the MBA online program that we're proud of. Do check it out. And with this, I invite the next finalist, Rahul Pednekar, who was working with Vodafone Intelligent Solutions. Rahul's expertise lies in creating data visualizations to tell his data story using feature engineering to add new features and give a human touch. Very important in the digital world today, human touch, in the world of machine learning algorithms. So over to you, Rahul. All the best.
Okay, thanks a lot. So first of all, I would like to wish everyone a very good morning. I would also like to thank all the juries, SNU and Machine Hack, for inviting me here to present my model. Okay, so let's get started. I have divided this problem into 5 simple steps. The first step gives me a helicopter view of the data. The second step gives me a deep dive. The third step where I pre-process the data. And the fourth one is where I add new features. So step number 3 and 4 are the most important ones, where I have spent maximum amount of time. And the fifth one is data modeling, where the algorithms are implemented and prediction is made. And last but not the least, lessons learned, because as they say, failures teach us more than success. So let me move on to the next slide. So as the first step, I got the overview of the data, how many variables, how many numerical variables, categorical variables, train rows, test rows. I also got to know that sales variable is having some negative values. Then I will start the deep dive here. So the first one I have taken as a sales variable, which is our target variable. So as we can see here, we can see a lot of outliers here starting 5,000 onwards. So that was one observation. And then here in the right bottom, you can see a correlation matrix. So for the sales column, we can see that the highest correlation is having MRP. So item MRP is the number 1 correlated item, and item visualization is the number 2 correlated item. Item weight is having the lowest correlation. So about item MRP, so it's kind of obvious that whenever a customer goes to a D-Mart or a big bazaar, the first thing that we see is the item MRP. Okay, and then the second thing that we see is the visibility. So let me ask you this question: how many of us are tempted to buy the chocolates which are displayed near the cash counter? I think all of us. So item visibility plays a very important role, and the correlation matrix is also showing us the same thing. I will move on to the next slide. In the next slide, we can see the distribution of the item weight. We do not see any outliers here. So I will move on to the next one, which is item MRP. Again, we do not see any outliers here. I have also displayed the median value for each of the numerical variables. Then item visibility. So here one observation, we can see that the item visibility is 0 for many of the items. Now this cannot be the case, because if item is sold, it has to be visible. You cannot sell something which is not visible. So that means there is something wrong with this data, and we have to pre-process it. So as a part of data pre-processing step, I have replaced all the numerical values which are having 0 values in item visibility column with the mean of item visibility column. I will move on to the next slide. So in the next few slides, we will see how the categorical variables are distributed based upon the count of the categorical variable. So for example, outlet year, we can see we have got maximum number of rows for 1997 and 2004. Similarly, if we look at outlet size equal to high, it's having lowest number of row count. We'll move on to the next slide. Here we can see the distribution of item type variable. Baking goods is having the maximum number of count, whereas here tier 2 location type is having the lowest count or the presence in the data. Then with respect to fat content, I would like to highlight that low fat is having maximum number of count versus the regular one, and outlet type, supermarket type 1 is having higher count than supermarket type 2. Now these two variables play an important role, which I will show in the next few slides. So here now I have plotted the categorical variables with respect to the average sales they have made. So we can see that for outlet type, outlet ID, outlet 13 is having the maximum average sales. Similarly, if you look at the year, 2007 year is having the maximum average sales, although we can see a lot of outliers here. Then in this slide we can see that outlet size is equal to high is having higher average sales, and the breakfast kind of item type is equal to breakfast in the last column, we can see is having the higher average sales as compared to the other item types. Now here we can see that how the item fat count is distributed against average sales. So low fat is definitely having slightly higher average sales than regular items. Similarly, supermarket type 1 is having higher average sales than supermarket type 2, which shows that definitely low fat and supermarket type 1 combination will give us more sales. Now here I have done some grouping of the categorical variables to see how they are related. So outlet location type, outlet size, and outlet type. Outlet location type, outlet size, and outlet type are grouped. We can see this tallest bar over here. So when the outlet location type is tier 1, outlet size is small, and outlet type equal to supermarket 1, we have got maximum sum of sales over here, is denoted by this. So the supermarket, suggestion to supermarket would be to look at the characteristics of these three combinations, and what is the extra thing that this three combination is bringing, which is not there in other supermarkets, other locations, other tiers. Then here I have grouped the items by the fat content, and I have found a new feature which says item type combined. So now item type is a categorical variable. I have extracted first two characters, and if there are only three variations, so is it either FD, which stands for food, NC, which stands for non-consumable, and DR, which stands for drinks. So now if we look at the combination, we can see that this highest tower we can see here is a combination of low fat and food items. So that means maximum sales are generated with food items which are having low fat. So that means people are health conscious, and supermarkets should try to sell more products which are part of healthy food. So for example, instead of selling Coke, sell Diet Coke. So here I have done a different combination again, outlet type, outlet location type, and outlet ID. So we can again see this tallest tower over here, which shows us that when supermarket type is 1, location type is tier 1, and outlet type is 35, has got maximum sum of sales. So all the time we can see supermarket type 1 and tier 1, it is giving us more sales. So something should be investigated more, what are the different characteristics, maybe with respect to the location, maybe with respect to the population density for the supermarket type 1 and location type tier 1, is helping the Mega Mart to make more sales using this combination. Now in next few slides I have shown how each of the categorical variable is behaving with respect to all the numerical variables. So let's concentrate on the last graph here, which says sales versus outlet year. So I have arranged it in ascending order. So you can see that the year 96 and 98, the oldest years we can say, apart from 1998, are having highest average sales as compared to other years. Then here we can see how outlet size is performing. So in the first graph you can see with respect to item weight, this outlet size equal to high is having the higher item weight, higher average item weight as compared to others. Then with respect to outlet location type, we can see again it is having a higher item weight as compared to other tiers, other locations. So here I have mentioned how item type is performing with the numerical variable item weight. So the breakfast type item is having highest average item weight as compared to meat, which is having lowest item weight. Then again item type with MRP, we can see again breakfast type is having higher MRP along with health and hygiene as well, and breads is having the lowest average MRP. Here we do not see much difference, with respect to item type and cells. So which also means that, we can see that everything is, on the same line, the mean part. So maybe item type is not, helpful in predicting the actual sales volume. Here we can see with item type and item visualization, soft drinks are having highest visibility and others and hard drinks are having lowest visibility. Then here what I have done, since there were too many item IDs, combinations around 895, I have taken top 10 item IDs by count and I have showed how they are performing against these numerical variables. So if you look at the last graph, FDD 41 is having highest average sales as compared to other item IDs. In this slide, I have plotted, I have done a scatter plot of item MRP and sales because item MRP is having highest correlation with sales, and I have used hue as outlet size. So we can see when the outlet size is medium or high, the item MRP starts at 100. So that is one observation. So we have covered now first point and second point in the previous slide. So this slide only summarizes them. So I will move on to the next one, which is one of the most important slides, data pre-processing. I have done around 4 or 5 types of pre-processing. So the first one we spoke already, that if item visibility is 0, replace it with the mean value. Then the second one is outlier replacement. So there were many outliers starting, 5,000 or so. One way is to get rid of all of them, but reducing them will result into lower RMSE score. So instead of that, what I have done is I have replaced them with value 6,000. And I have replaced low fat with low fat and reg with regular. And I also removed some train rows which were not present in the test rows. And the last one is this outlet year. So I have converted it into object data type. So earlier it was numerical one, so I have made it as an object data type. The most important slide is the fourth one as well, which is feature engineering, wherein I have added multiple features. So the first feature is very important. I have created an item ID rank based upon item MRP. So we know that item MRP is one of the most important features to decide the sales, and each item ID is having item MRP. So what I have done is I have found the mean of the item MRP for each item ID and ranked them in a ascending order and assigned rank 1 to the costliest item ID. And the lowest rank is assigned to the cheapest item ID. So I have converted now item ID field from categorical 1 to numerical 1. Then I have also found a new feature, which is by extracting the first 2 characters of item ID. Then I have created new columns which says perishable and non-perishable. So for example, dairy is perishable, but hard drinks are non-perishable. And I have another category not known, which doesn't form in any of these 2. And then, as we discussed that if the outlet is older, it may add more value because of the customer relationship. So I have formed a new feature by subtracting the establishment year from the current year, which is 2021. And last one is target encoding. So in target encoding, I have calculated the average sales for each of the categorical variables from the train data and mapped it to the test data. I will move on to the next slide, which talks about the model building and evaluation. So here I have, first of all, created dummy variables for categorical data. Then I have started with a basic model with 7 algorithms: XGB, LGBM, CatBoost, lasso, rich, elastic, and linear regression to get overall idea of how the models are performing. Then I have started with hyperparameter tuning using Optuna library with 30 trials and using k-fold cross-validation again for the 7 algorithms. I have done out-of-fold prediction, for each fold, get the best model, predict on the test set, and then at the end take the average of all the test sets. Then I have done ensembling as well. I have, defined weights starting from 0 to 1, and then incremented in the manner of 0.05. And, and select the model which gives us the lowest RMSE. But that also did not work, and finally I ended up choosing the only single model, that is CatBoost regressor, which was hyperparameter tuned along with k-fold cross validation. We can see two top features at the top, item MRP and item visualization given by the LGBM algorithm. And the last slide, lessons learned, which is the most important one. So these are the 9 things which I had tried, but they did not work, so I had to skip them, but worth talking about them. So removing of all the outliers, then binning of the item MRP, weight variables, taking log of the variable, standard scaling, ensembling with the weak models, then imputing cells is equal to the mean value for all the negative values, polynomial regression, dropping item weight column because I thought that may not add any value, and merging years 2005 and 7 because they were having multiple outliers. Yeah, so that's all from my side.
That was fantastic.
Yeah.
Just in time. So over to the jury and for the questions for Rahul.
Yeah.
So what is your final recommendation here?
The final recommendation is the supermarket should sell the low-fat items. They should concentrate more on the tier 1 cities and supermarket type 1 because that combination is giving them more sales result. At the same time, they should investigate what are the typical characteristics associated with this combination which is giving them more sales results as compared to the other one. Maybe it is the population density. Is it a metropolitan city like Chennai, Mumbai, Delhi? Is it the location of the supermarket? So what is it that is causing more sales? So if we can investigate more also on the item ID part, like if this particular item ID is giving me, what is that item ID? Is it a toothpaste or a toothbrush? What kind of item it is actually? Also the ranking of the item IDs will help us giving those insights because we know like now which item is having the maximum average MRP. And since MRP is the main factor in deciding sales factor, we can drill down to item ID and see why this particular item is giving us more sales.
So two things. One is you said that item visibility where it is 0, you substitute it by the mean.
Yes.
So would not it have been better to substitute it by the mean of item type rather than the mean of the item visibility itself?
Yeah, so I have tried doing that as well, but in item type I saw a one-to-many combination. So one item ID is appearing under multiple item types. So you will have one item ID appearing in household as well as it will be part of the soft drinks as well. So it was very difficult to make out that which item is part of which item type. So there was no one-to-one mapping as such. So that was the reason I was not able to.
You did try that.
I did that. I did try that idea.
And did you find out what are the characteristics of supermarket type 1 versus 2?
Supermarket type 1 characteristics were, first of all, they were having average sales and they were selling more low-fat items and they were, the combination with tier 1 was giving more results. And I think that supermarket type 1 is the place which is, from metropolitan cities like Mumbai, Chennai, Bangalore, which is densely populated area, and outlet size was small. It was not a big outlet. So you have more population, small outlet size, and you are selling it in a big metropolitan city. So that combination is giving more sales.
Okay. Fine. Thank you.
Yeah. Okay. Thank you.
Okay. Thank you, jury. Thank you, Rahul. That was very well done. And next, we have a presentation by Mukul Sharma, who is a manager at Niva Bupa Health Insurance. And he's an aspiring data scientist with an engineering majors in electronics. And he's experienced in supervised machine learning for fraud detection, unsupervised customer segmentation and visualization for portfolio management, graphs, and automation. And he does have a very unique and interesting presentation style as well. So over to you, Mukul. You can take a look at this when you present if it's convenient.
Good afternoon. I'm Mukul Sharma. I'm a data analyst. Let's start our presentation. So let's start from the data itself. We have 12 columns. We have more than 87,000 rows for the training, more than 37,000 rows for the test. We have 6 variables regarding the items, 5 variables regarding the outlet. Sales is our target variable. But the very first insight we can see is there are 397 rows with negative sales. Then we can see there are rows where the item sale is actually less than the MRP, which means it's either a garbage value or items were sold on a discounted value. When we create a complex key on all the categorical value variables, we can see that there is a duplicity, which means either the same item was sold at the same place, but with a different weight and different price, and it impacted the sales as well. For the year, we have 2005 and 2007 as rare years. Now, so I'll tell about the graphs. So the bar plot is the count. That orange line is average sales. On the right-hand side, you can see the orange line as average weight and blue line as average MRP. We can see that fruits and vegetables are one of the highest selling products, whereas the average sales for them is one of the lowest. Also, down below, we can see the visibility factor, where hard drinks are on the lowest scale and soft drinks are on the highest scale. Next come outlet ID, outlet 35 on the maximum. Now comes the outlet size. We have high, medium, small. High outlets are giving highest average sales, whereas we have maximum of small outlets. Now let's come to the outlet year. There is a special cyclicity for the sales in the outlet year. We can see 2005 and 7 are again rare years. For the outlet location, we have maximum in tier 1, then comes tier 3, whereas the maximum average sales come from the tier 2. Now outlet type, type 1 is dominant as far as the number goes for the sales as well as the counts. People are more considering low-fat items. The average sales are higher for them as well. Now let's come to the data preparation part. I made 5 folds. There were 2 types of variables made. Number 1 were global variables, which were prepared before the cross-validation and on training plus test data. And then there were cross-validation specific variables that were actually prepared on the cross-validation loop, prepared from the trained data, and then mapped to that validation as well as test data. Let's start. So what I did is I converted all the negative sales to the positive. I did the absolute number. Then I dropped all the rows where the item MRP was greater than the sales. Then I recategorized item type. Some of the items were clubbed to the others category. Rest items were taken as it is. There were 3 interaction variables were made regarding outlet for outlet size and location type, outlet ID and year, outlet size, location type, and outlet type. Also, item fat content was recategorized only with 2 values, low fat and regular one. So item ID is actually a 5, the length of item ID is 5, where we have 3 alphas and 2 numerics. I created 2 new variables out of it. One is just alpha, one is just numeric. So we have item ID 2 and item ID 3. Now, item weight and item MRP are consumed as direct variables, numeric variables. There was no binning required. In the cross-validation loop, I did a frequency encoding of item ID 1, 2, and 3 on the training, then mapped to the validation and test. Then starting with that, I did a leave one out encoding on sales variable. I did target encoding on item MRP. I did a target encoding on item weight. I did it for the item FC2, type, outlet ID, outlet year, size, location, outlet ID year, and location type 2. The list of final variables is available on the next year one. I use SHAP values in every iteration for the feature selections, and final feature was selected on that basis. Now comes the model building and evaluation part. So I used a cat boost algorithm, since it can cater all the categorical variables very well. In the second part, second point, we can see all the variables that are given as categorical in the algorithm. Now, since the features are learned and mapped in the cross-validation itself, and I am using leave one out encoder for the sales, so it leaves very less room for any data leakage. Now, also, I used early stopping round to cater the overfitting. The RMSE of validation and train were used to select the final model. So I did the hyperparameter tuning manually, although I employed Optuna as well, but the final parameters of my manual hyperparameter tuning were better. I also tried other models like simple light GBM, a combination of light GBM plus cat boost, but the standalone cat boost was giving me a better RMSE. Again, from the shape values, we can see, so the very first variable is outlet ID year target encoding. It means the leave one out encoding of outlet ID year over sales. Second is standalone outlet year. Other one is item MRP. Then we have outlet year target encoding, means leave one out encoding of outlet year over sales. Then we have standalone outlet ID year. Then I have item type target encoding, which means leave one out encoding of item type. Now comes the results and recommendation part. As per the model, outlet ID year target encoding contributes positively to the sales, and similar trend can be seen for item MRP as well as outlet year target encoding. But things get tricky when we comes to the outlet year. Here, the higher the values of outlet year, the positive contribution towards the sale, and the higher the values of outlet year, there's a negative contribution to the sales. It is what I interpreted from the model using shape values, and it can also be connected to the cyclic behavior I have showed you earlier. Also, the deployment of all the 5 models is recommended. The final prediction will be the average of all the 5 models, and all the encoders and mappings can be saved and we can be used at the time of inference. Model can be deployed as REST API using Flask or Fast API. And if the business tells us any handcrafted rules which should be applied over and above of our daily model inferences, which it can also be employed. So now, this is the result and recommendation regarding the data. So what I did is I plot a pivot of supermarket type, outlet type, outlet size, and outlet year. You can see a very peculiar number here, which is 1600. This number is small, is the average sales, and this is smallest of all the given combinations. And this is not a very small population. We see that total population is actually 14% of all data. So this 14% population is actually driving the business low. We have least average sales for the supermarket type 2 in tier 3 with medium-sized outlets. Also, if we see the supermarket type 2, out of all the supermarket type 2 outlets, 88% are in the tier 3 segment. So we should look at what's happening around this supermarket type 2. Whether we should convert them into supermarket type 1, or should we convert their sizes, or should we shift them, or is there any underlying problem going on? Second, so just a minute. So tier 1 and tier 2 outlets are basically small size outlets, and we can see the accounts in tier 1 is highest, but the average sales is better in tier 2. So there is actually a room for small outlets that should be presented in the tier 2. So we should incentivize the small outlet creation in tier 2 so that we can boost more sales. So fruits and vegetables, as we have seen, fruits and vegetables are one of the highest selling products, whereas the average sales are pretty low, but these are staple items. So we should actually put these items towards the end of the outlet, and we should put items with higher margin, for example, small energy drinks or candy bars at the very beginning of our outlet in such a way, so when customer comes in, they look at the counter. When the customer is roaming around towards the final fruits and vegetables, they're actually looking those high margin products. And when the customer is checking out, at that time they have 1 or 2 minutes, they are talking with the cashier or doing something, they are tempted to buy those products, and which in terms boost our profits. Now, recommendation type final. So this is actually an experimental business model which I'm presenting to you. This is inspired from how Asian Paints works. So here we should start incentivizing small outlets spread throughout the city, coupled with the logistics systems which can deliver products to the outlets every single day or every other day. So the benefits here are, number 1, small outlets require less inventory, less lease, less equipment for refrigerations, and less people to handle. Number 2, since we are actually spreading these outlets throughout the city, we are creating small pockets, which in turn makes our reach and visibility to the customer more. Number 3, Since we're actually buying the articles on a scale, we're actually buying for a major warehouse in the city and then distributing to the outlets, which means we can leverage the scale of price. Now here comes the part of our distribution system, which is logistics system. So since the size of outlet is small, but it actually catering all the required items, so the quantity is very limited. Let's talk about perishable items. For example, mushroom. So let's say the impact size of our outlet, small outlet, is 3 kilometers, and on an average, 5 kgs of mushrooms are to be consumed for a 3-kilometer population. Now we are going to put only 5 or a little bit of more mushrooms in the outlet so that all the mushrooms are consumed on that day, and the trucks comes on and it replenishes those products. All the perishable products as well as the frequency for breads or frequency for packaged food items will be different, but there is a frequency. So we are actually the same theme we are doing, where we have higher frequency of this logistics and low quantity, so that we can give better options. Now, so here is another thing. Let's say a customer comes to the outlet and that item is not available currently, or let's say the outlet actually never sells that item, but we do offer it on warehouses and all. So now customers have two options. Number one, either go to a bigger outlet, which is 5 or 10 kilometers away from ours or maybe others, or order online. But there is also a third option. Let's say customer had a conversation with an outlet owner and said, okay, so I want this product. When's the first time you can get me? Since our trucks are moving anyway, we can actually call to the warehouse and say, hey, can you get me this product? Now, since trucks are moving, we don't need any delivery charges, even if that item is less than 500. But for the online sales, we have for items less than 500, companies like Big Basket, etc., actually charge the money. So here we can actually create a loyal customer base, and we can deliver fresh items to the customer in every day, or for other package items in every 2 or 3 days. Also, since we are actually dividing all the geography into small outlet system, we are actually creating profiling. Here, let's say there are people who take ration every month, and we build a subscription model where, okay, on every first week, this quantity will be delivered to you at your home, because since outlet is impacting 3 kilometers, they can actually deliver to home as well. Now, since we have all this small area, and we have this small population to cater, what we can do is we can create profiling of that particular location, and we can create small profiling pockets. Now, the helpful point here it is, after profiling, we can actually go for targeting campaigns, targeting marketings. Also, this gives us another power of experimenting. We can have a product launch on 2 different outlets, outlet A and outlet B, and we can see which product is buying at which outlet. So this sort of products are more, have buying more capacity in the outlets, has more buying capacity in the outlets. Now you may ask, delivering every day is a daunting task, how we are going to do it? So let me present you Asian Paints, the study of Asian Paints. Asian Paints deliver to 70,000 places 4 times a day. After every 3 hours, that calculates it to 2.5 lakh to 3 lakh deliveries every day. And it's not they're doing from today, they're doing it from decades. That started from 1970. I'll highly recommend watching a YouTube video of it. So now, after every 3 hours, so whenever you go, or your contractor goes to Asian Paints, they actually buy the product. Then the 3 hours, a truck comes in, replenish that product. They're doing it every day, 24/7, and it actually made Asian Paint as a money-making machine. Thank you. That's it, and these are the final variables which I used. Questions, please.
Yep. Thank you so much. Now over to the jury.
Thank you very much for the presentation. In terms of the final recommendation that you have placed, and something that you mentioned in the inspiration section.
I'm heartily sorry, sir. You're inaudible.
Can you hear me now?
Yeah.
Okay. So what you mentioned in the inspiration section, I'm slightly confused. What is your key recommendation? Is it towards expansion, or cost optimization, or increasing sales, or completely remodeling the business, which is changing the dynamics from all products stacked to just perishable and versus delivery store?
So there are, if I can go on a slide, can I?
Yeah. Can we have the slide, please?
So on the third last slide, can you please move to the third last slide? Third last.
This is
no, this is not mine. So in the third last slide, I'm actually presenting what's the issue with the data, the supermarket type 3, supermarket type 2, tier 3 with the medium-sized outlets. So that's what we are actually losing. That's where we are actually losing money. So if we want to, get more better sales, better profits, we should look on this 14% of population. And then I'm giving an experimental business model, which can be thought of as an innovative idea for the future recommendation, but should be, we can pivot to. Given all the nuts and bolts, whether it will be profitable given the scale.
Sorry, and did you also simulate the data basis what you're recommending? So let's say your recommendation is X to make certain changes. Did you simulate the data to see if your recommendation is effective?
The last one, sir? Which one recommendation are you talking about?
Any recommendation. So whatever you're recommending to me as a business, as a business owner, I will be keen to understand that what is the efficacy of your recommendation. And the way you can achieve that is by simulating, by remodeling the data, or creating a sample data set and see, let's say if you're recommending to focus on tier 3, medium size, if that increases, what will be the outcome?
So I didn't actually simulate it. I just did a eyeballing for that, honestly. Like for the tier 3 on the above and all, on the horizontal line, we have different averages.
Which is fine, that I can see. Okay, thank you very much. I have my answer.
Yes.
Mukul, could you elaborate on the replenishment strategy that you mentioned about, wherein you said the trucks are moving all around the city, and let's say if a store runs out of a particular product, you can just stop the truck and ask them to come and replenish.
Truck is actually coming on every morning. Okay. So right now, suppose I am the outlet owner, you come to me, Mukul, I want certain product. When can you make me available this? So the first time is in the morning. Trucks are not coming. So Asian Paints is doing this 4 times a day thing. I'm talking for once. I'm not talking about trucks are moving and all. It will actually increase the...
so when do I place my demand for the day? In the morning?
Yes, ma'am.
So when should I actually place the demand for my store? At what time of the day should I be placing my demand for the day?
So you can place the demand any time of the day. It will be available. If it's not available right now, the first time it will be available is the next morning.
So let's say today at 2 p.m., I run out of my stock and there is no safety stock available. And
which stock, ma'am?
So there is no inventory available.
Okay.
And there is no safety stock also. So let's say there are 80 units of product A that needs to be sold. Okay. And I keep 20 units as my safety stock because I see that, that there might be more demand. But at 2 p.m., I've run out of all my products, okay? There are no units available. The peak selling hours usually would be during the evening. With this strategy in place, am I not losing out on the sales during 2 p.m. to 10 p.m. at, point of the day when I might actually be able to make a lot of money?
Well, then, talking about the data, we should rather think about it at what location the outlet should be placed, what population it is actually impacting. What is the average sales of that product, what's the peak hours, and then we should calculate at what time truck should come, whether truck should come only once in a day or twice in a day.
And who decides this?
Yes, ma'am?
And who decides this? The store owner cannot actually decide at what point in time the truck should come, right? So, and this cannot be very dynamic.
Yeah, it won't be dynamic depending on the outlet owner. But the team behind the whole business, they decide at what outlet, when truck should be coming. So in Asian Paints, what we do is, so the dealer, they don't know at what time truck will come. They don't know what paint will come. Just a minute. So area manager gets an email early morning the day with the details of loaded truck. The paint gets sold within 3 hours. The dealers don't even get to know about the colors that come every 3 hours in the consignment, not even the size. So what I'm saying is the outlet owner doesn't know what size, what shape, at what time it's coming to be. It's all about the analytics team who decides that, depending on the data. So that's an inspiration which I believe we can take from the working of Asian Paints. Okay. If they are doing it, I believe maybe it's doable. Okay.
Do you think this is a sustainable strategy?
Well, on a scale, it can be, depending upon how many people were catering.
Okay.
But we cannot compare this with the supermarket. The paint gets sold in 3 hours. So what you're saying is the inventory at the supermarket gets sold in 3 hours. For the rest of the day, if the supermarket is opening for 12 hours, 9 hours, there are no customers because there's no inventory. So I think
saying for the 3 hours, people, 3 hours are peak hours, but 9 hours, the outlet is empty.
If the paint gets sold within 3 hours, right? So whatever the stock is gets sold in 3 hours at each outlet. That means there is no inventory available?
Some paint is sold. I'm not saying the whole, no one buys, so I'm not saying the whole outlet is over. I'm saying, for example, a black paint of this much liter is sold. They know at that point, this much paint will be sold, and then they deliver that paint only. I'm not talking about the whole outlet. I'm not talking, so for example, let's say there is a dealer in Mumbai at some place, and so the company knows, so then there will be a vacancy of this much paint, of this much color, of this much quality and quantity, and they deliver that. So it's not the whole outlet is vacant at any point of time. Any more questions? Thank you.
Thank you so much, Mukul. I don't know if you convinced them, but you definitely got their attention. So we have the next presenter, Rupesh Prasad, who is a manager at TCS. He's worked with premium organizations such as AIG, Citi, and Cognizant in the past, and has ample experience in predictive modeling. He has over 9 years of experience in the BFSI domain with a demonstrated ability to deliver valuable insights via data crunching and data science techniques. So, Rupesh, can you have you? All the best.
Hello everyone. First of all, I'd like to thank Machine Hack and Shiv Nadar University to provide this opportunity. So, yeah. So I'll first start with the data understanding part, and then slowly we'll go through all the slides. So obviously, as we have already seen in the previous slides, here the objective was to come up with a model to predict the sales of product from each outlet. So this is a quick data summary. The data which was provided to us was having around 87,000 records in training, around 37,000 records in test, and the time zone for this data was 1987 to 2009. So this is basically the time when the particular outlet was open. So this is a very quick thing. There was no missing. The data was comparatively very clean. No outliers were observed. There was no correlation among the numeric variable. And talking about the mode of trained data, when I basically say mode of trained data, I basically mean most of the records came from this combination. So for example, in train and test, if we see, most of the records were coming from outlets in number 18, medium size, and they both were coming from tier 3. So this is true for train and test both. But when we try to see the type of things which were getting sold, in case of train, it was fruits and vegetable. But in case of test, it was basically snacks food. And on the right-hand side, what you are seeing is basically the distribution of our dependent variable. So as expected, it was sort of positively skewed. We had few values on the right side, which is quite expected in case of any price variable or the sales variable. And we had some variables below 0 as well, which is not possible. So obviously, since it's a positively skewed variable, so taking a log was already in back of my mind because it will avoid all sort of outliers and everything. And it was basically flowed at 0. So that because sales can't be negative, so yeah, that was the idea. Now, in this particular slide, what we are trying to do, it's a very quick slide. Here, we are trying to understand the relation between sales and all the variables which was provided to us. So the first part of slide, what you are seeing is basically the scatter plot between sales, which is my dependent variable, and all the X variable, which is item weight, item visibility, item MRP, and so that outlet year we can avoid. So as we can see, there is no evident linear relationship among any variable. Apart from that, that heat map is also telling us the same thing, that there is no correlation at all. And then the bottom half of this chart, what you are seeing, this here I'm trying to see that whether the categorical variable have any information regarding sales. I mean, so for example, this particular graph, what we are seeing, we can see the mean across all the outlet size category, be it small, medium, and high. The mean across the category are same only, and the same holds true for all the other categorical variable. So this slide, the conclusion is that, you know, in linear world, we cannot find a model which can help us to predict the sales. So we may have to go to a non-linear world. So yeah. Yeah, so this is the data preparation part. It's a very quick one. Here it's like, as we already explained in the previous slide, there was no missing outlier, and so all those things were not required. Apart from that, various features were created. The first one was outlet age, and apart from that, we had average item weight across item type, average MRP across item type, and the combination of few categorical variables. So these were the different type of variables which were created before going into the final model. And finally, the data was split into 80-20. So this is the overall modeling flow. So the first 4 icons, whatever we are seeing, already I have explained. So it's like data set, and then started with the exploratory data analysis, feature engineering, train test split, everything already explained. After these 4 steps, what I did, I tried various vanilla models. So when I say vanilla model, I basically mean the model without any sort of hyperparameter tuning. And based on few criteria, I selected these 3 models. So when I say few criteria, I basically mean total 2 criteria were there. The first, that we should have the lower RMSE, lowest RMSE possible on the test data set, I mean on that 20%. And at the same time, there should be very less difference between the train and test, so that we can avoid any sort of outliers in future. So after that, on these 3 models, I tried doing the hyperparameter tuning, and then compared the error on train and test, and the final model was the cross-validation model, and this is the final prediction. So we'll go to the next one. Yeah. Now, if we go through this feature importance thing, as per the cat boost was obviously performing much better than these 2 things, but here is a catch. In case of cat boost, if we try to see, the outlet age is coming out to be the most important variable. And in case of light GVM, it's item visibility. In case of XG boost, it's outlet ID. Now, even though this cat boost looks to be a very good model, but the catch over here is this outlet age. If we think from the deployment perspective or the future perspective, this may create a sort of bias, because we may not have this age thing for a new outlet. And apart from that, one more point, there are a lot of items which are sold nowadays and they were not sold during 90s. And this data starts from 90s. For example, things like Nirma, or there are a lot of stuff which we used to sell during 90s, but now we don't have those things available. But somehow this cat boost, what it is doing, it is giving very good score on leaderboard, everything, but it is taking outlet age as the best variable. So it's good as per the hackathon, but talking from the deployment, I personally won't go only with the cat boost. So that's why I tried the other models as well. So from modeling perspective, these 10 variables, these are the top 10 variables from each and every model, and they can explain around 90% of the variable in their respective data. So basically most of the variables are common among them, but the top variable, as we can see, are quite different. Yeah, so the final model, this is what is my final model, but again, I'll come to this deployment point of view. From deployment point of view, if I have to go, I'll only go with the light GVM model because of the following error. The first thing, it has the lowest train and test error. The second thing, it takes the lowest time to execute. And obviously, it doesn't involve any sort of bias or something like that. And how can this model be deployed? Obviously, it can be deployed using a framework like Flask, wherein we'll have a very simple app. In that app, just people have to enter all sort of input variable and just click, and then the sales should be calculated, means expected sales. So these are some recommendation. Now, okay, let me go like this. This recommendation I can basically classify into 3 parts. The first part of recommendation would be something which is directly coming from the model. So for example, this second and third item, where for example, item with very less expiry period can be supplied to an outlet where the expected sales for that item is high, so that it can be consumed very quickly. And how we can calculate this expected sales using this model. So for example, let us say there is a new item. That item can be categorized in the category of food and beverages. So we can calculate, if I supply this item item into this particular outlet, in this particular tier, what would be the expected sales. So in this way, there will be a lot of combinations which we can create, and wherever we find that there will be, there is going to be very high expected sale, so we can supplement that store with that type of item. Similarly, if we see the third thing, the average sales for the medium outlet side in tier 3 location is lowest. So we can find the items whose expected sales would be high for this location, again using the model, and supplement the stores with this item. Now, again, so this is just from coming from the model, and if I have to personally give the business recommendation, I will give this model recommendation only 40%. My remaining 30% will basically be just using the data. So it's all about churning the data. Just by doing the EDA or churning the data, we can get a lot of, insight. For example, the first one. Now, in first one, we don't have any sort of model, used. For example, canned item have very high sales in small as well as in high outlet size, but they have very low sales in case of medium type outlet. So why is this? Is it because of low demand or low item availability? So in the moment we find answer to these questions, decisions can be taken accordingly. The other thing which we can directly get from EDA is something like Pareto analysis, where and it is well proven that 80% of the sales basically comes from the 20% of your top products or something like that. So the moment we find there is a combination of tier outlet where sales is very high, and obviously we'll be able to find so what exactly we are doing in that particular outlet, and those learnings can be applied to other stores as well. So that will be the second 30%, and my final 30% what I'll give to something called the field study. So that field study won't use this data at all. It will be something related to customer behavior. So customer behavior as well as demand. So for example, if Walmart has to open one retail store in India and America or US, so obviously they can't have the same type of item. Second thing, customers changing behavior or changing demand. So for example, in and around Delhi, if you see during these festival times and all, like during Navratri and all, you will find that non-veg item have almost no consumption and all. So those type of things are not available in other places, but here we have. So those type of things we can take into consideration. Apart from that, inflation rate, interest rate, so they also somehow directly or indirectly, they are also proportional to the customer demand or customer demand and all. So that also can be a factor to decide that, whether the sales can be high for that item or not. So I'll finally, this is how I'll divide. And one thing is like, yeah, for that. Yeah, again, coming back to this particular slide, since we can see this outlet age, so while taking any decision, we have to avoid this outlet age. Why so as I have already explained, because already it has been 20 years and we have the data over 20 years, and I don't think 20-year data makes sense. So maybe it's like, in case we want to go for the models, we should have a different model. One model for this entire 90s and one model for last 10 years. Because I personally believe it doesn't make sense to have a model on these entire 20 years. So that will be one thing. And yeah, so obviously this is how it can help us to have the better business decision, allocate the item across stores, manage its cash flow. Will we get the early signals of any sort of risk or any sort of profitability? Yeah. Thank you. Any questions?
Yeah.
Points? So to the jury.
One question I have. Thank you for the presentation.
Thank you.
So you used a combination of 3 methods, XGBoost, Light GBM, and CatBoost.
Yeah.
Why, I still haven't understood why you did that and how you decided on the weightages.
Can you please come again?
I want to understand why you used a combination and how you used 0.3, 0.4, 0.3 weightages for each of these.
So if you see,
isn't it more effort and resource intensive to do all 3 rather than going down to one of them?
Yes. Yeah. So if you see for the CatBoost, it's like the score which I have given is 0.4, so which is highest. So because it was performing very well on leaderboard, on our cross-validation scores as well. So I did 10-fold cross-validation. There also it was performing really very good. But again, the point came like I was using their outlet age. And if I am using this particular model in production or in my company, no one will allow me to use that particular age or something like that. So obviously with after this model, I went for this Light GBM and XGBoost. So these 2 things also were giving good results, not comparable to CatBoost, but it was giving good results. So, since total has to be 1, total weight has to be 1. So 0.4 already I gave to CatBoost, so it was divided into 0.3 and 0.3.
Any other questions? Oh,
So some,
yeah, please.
so here like you showed tier 3 has lower sales.
Yeah.
Right? And so did you also go to the extent of seeing should some stores be closed? Did you also
See, if we have to go through that thing, so that's what I am trying to say. We don't even have to go to the models to do all those things. So, for example, if I go just the simple Pareto analysis, and I come to know, okay, these 20% stores are really giving me 80% of the profit, and obviously, if I come to the bottom, I'll come to know that even though these 60% stores are not giving me any profit at all, something like that, or giving me very less profit, and from there we can simply exclude the thing, obviously based on the business recommendation and all, and for that we really don't need these type of models and all.
Okay, thanks.
And Professor Ghosh has a question. So if you could just get in the mic. Just a sec. Just a sec.
I'm saying the assignment of weights has no statistical significance. You did not do a simulation or anything like that. So it has to have some subjective bias.
Mm-hmm.
So how do you address that?
So it's basically, what I want. Basically, the whole idea is that the model which I am building should not fail in future. It shouldn't be some overfitted sort of model that it has, because from hackathon perspective, if I tell you, we only get to see 30% of the entire data. Right. So there is a good possibility that the model which I have built will perform very good on this data and it may fail. So obviously the combination of model has a very good chance of not failing than using a single model.
But this has no statistical basis.
It has one statistical basis in this particular slide. So that so that variable important slide. So for example, if you see for cat boost, outlet age is coming out to be important, but we can leave it aside that outlet age is not something to be used and all those things. But if we go to light GBM, right, then if we go to light GBM, then the item visibility is coming out to be the different feature. But if you go to XG Boost, then the outlet ID is coming out to be a most important feature. So what it is saying that all these models are trying to capture different dimension of data.
Yeah, but this is one particular realization.
Yeah.
You should have done an ensemble technique to just simulate over the entire complete run of all ensembles. Because, this is one realization. It's not so it has to have bias.
Yeah, it did.
So you understand what I'm saying?
Mm-hmm. Right.
You should have done what you did is right for one realization of the process.
Right.
But you should have run it over, 1 million realizations to come up with weights. Because otherwise, you're specializing to one particular realization, and that will bring in statistical bias.
That's why, so I completely agree with you, sir. And that's why there is one more point which I have completely mentioned over here. From deployment point of view, I'm not going to have some, some 10 sort of model and just say, okay, deploy this in production. Because no one will do that. That's why I'm saying that I will only go with one particular model, and that is light GBM.
That's right. But the question is not one particular model. It's one particular realization of one model. So I'm saying if you could have done a Monte Carlo type simulation for this one model, but with randomly generated synthetic data, then you should have come up with statistically significant weights.
Right.
But this is just, your choice.
Right. In my defense, I have just one point. You are 100% right. For example, all these models are not the direct models. They are like 10-fold cross-validated model. So for example, for each and every fold, we try to see what is the exactly, RMSE or the error we are getting. In case there is a huge difference or variance among these 10-fold, obviously I have ignored that type of model. Yeah. Thank you.
So any more? Okay. So great, yeah. So great going.
All the best.
And now, do we have my namesake? Okay. By the way, my name is also Rajat. So we have Rajat Ranjan, who is a data scientist at the math company with rich experience in premium companies such as Infosys. Rajat is a full stack engineer along with a portfolio in machine learning and data science using the latest technologies. He loves competitive coding and taking part in machine learning hackathons to play with data and create robust models. Good to go, Rajat? All the best.
Everyone. So myself, Rajat, and first of all, I would like to thank Shiv University as well as Machine Hack for giving me this platform to describe my solution in front of the esteemed juries and judges. So moving ahead with my presentation, for this particular analytics Olympiad, we are predicting the sales around different outlets for different years. Okay. So our main, in my perspective, our main objective is to present that how the sales are basically affecting by different items and around the outlet IDs over the years. Apart from that, what is the business implications that we can present out based on the data that we have. And lastly, the consulting ideas to the SMEs who will basically, have the data insights and basically provide to different clients and judges. So moving ahead, so this is just the introduction part, okay. So, yeah. So first of all, I'll go through this particular use case understanding. So as a matter of fact, so this is a very great example of, I think, most of the big mart sales, okay. And in this, basically, we have different outlet IDs, we have different product IDs, item IDs, and we have the sales around for each and every outlet over the years, over a period of time from 1990 to different one. Okay, so basically what I have presented here is that, and our main objective here is to predict the sales, okay. So first of all, there are some few EDAs which I like to present to you, okay. First of all, we have the different outlet IDs. So for all in all, with the whole our data, we do have only 5 different outlet IDs, okay. And these are the mean of sales which are actually presented here. Moving ahead to this particular slide, so we have sales based on outlet IDs, okay. So we have different, I think, around five outlet IDs. Based on that, in 2005, for example, if we go through the chart, we can see in 2005 we do have the minimum number of sales, and for certain, yeah. In 2005, for outlet number 18, we have literally no amount of sales due to some macroeconomic factors which we don't have actually the data set provided. So that is something which we can basically look upon, and we can try to modify it. We can try to inculcate that what is the basic reason around it. Apart from that, we can see that 2007 it's actually amounts to most number of sales, okay, for outlet number 49 as well. So these are few of the analysis that actually we did over the years, for example, from 1987 to 2009. And these may also present a kind of a trend seasonality of the sales, which we can basically say and to explain to our customers or clients. So moving ahead, so these are some of the outliers which I actually find, and so basically we used the interquartile range, okay, to basically check for the outliers and what it is. So basically for different outlet IDs, we have presented different number of the basic box plot, okay, which will show us that what is the different sales outliers that we have, and we have to correct it out, okay. So not only based on the outlier IDs, obviously we have different outliers related to the item IDs as well. So we have around, I think, 1,500 different item IDs for different different outlet IDs. So yeah, moving ahead with this one. So basically in this particular EDA, what I'm trying to show here is we have the sales based on outlet features. So we have, over the period of time, what are the sales and, how the different outlet location type or the outlet size are actually hampering, or what is the analysis that we can basically get from it, okay. So we can see in 2007, we have a, very much round of sales, okay. So obviously, we can see that, in tier 2, it is the most amount of sales that actually has been recorded. So there must be some kind of, economic factors, or we have, different, for that particular tier, for that particular outlet ID, obviously there are something which is, which is boosting the sales around that particular thing. So that is one thing. Based on the outlet size as well, so we can see basically we have the maximum number of sales, but yeah, they are in accordance with the outlet size. So no matter the outlet size, but we have, the common amount of sales, which is with respect to the 2007 year. Okay. Yeah, so moving ahead with the next slide. So this particular pair plot which I have created is based on the outlet IDs. Okay, so we do have a few, points that I need to mention here. Okay, so the variance in plots in these, sales, the item weight and the item MRP for different item IDs around the around the outlet IDs. So these are actually some of the EDA part which we basically see and try to find out that what is the basic implementation or what are the insights that we can gather as a data scientist or as anyone to present to our the clients. Moving ahead, in 2010 we can easily see that we have the outlet number 18 which is presented there at the most amount of sales. And yeah, so yeah, this describes basically a kind of a all-in-all structure for the different item features based on the sales that we have. Now, moving ahead, obviously, whenever we get a data set, we know and we do need to do some statistical tests around it to understand that what kind of data that we have. Is it in accordance with whatever the normality test, or for example, if we are trying to compare two different categorical variables, so we do have different statistical tests which we need to understand and which we need to modify, or they will help us modify the data in accordance. So I have performed actually 3 types of tests, which is first of all is the Pearson chi-square test, which is mainly used for for checking the independence for different categorical variables. So I have used item ID as well as the outlet ID, which concludes us that the p-value was actually very much less than 0.5, which is the alpha value, and shows that they are actually independent. Apart from that, for item features, I have included the Shapiro normality test, okay, which it shows that actually right now they are not normally distributed. So for example, item weight, it is, as the other participants have also shown, that it is kind of skewed, okay. So these are few things, and last but not least, obviously we have to understand and that how the sales are actually affected by different item features, all the numerical features that we have. So for that, I have included item weight, item visibility, as well as the item MRP. So basically, from this test, I can show and basically tell that okay, the sales are not totally normally correlated from item weight or item visibility, but yeah, it is closely related to item MRP. Okay. So this was about the statistical test that we did. Now coming to the data preparation part. So obviously there are few of the data analysis and data preparation that we used to do. So first of all, we have to check that what are the outliers that we have based on outlet ID or the item IDs that we have. So that is one thing. Apart from that, if there are any null values which we need to impute in the data frame or not, then we have obviously in any of the particular data set, we do have some categorical variables or as well as numerical variables. So in this particular data set, what I have done, so I have taken few of the categorical features here, which are like item ID, item type, okay, and I have, so these are basically some of the raw data features that were actually provided to us. Based on that, so we have numerical data and we have the dummy variables, which are one-hot encoded for the model to present. So there are some of the important points which I like to mention here. So the outliers are actually treated based on the interquartile ranges. Then for me personally, the feature engineering did not improve the model performance. So the raw data was the main thing that I was actually focused on, and the statistical hypothesis testing which I used, okay, and basically the features manipulation that we used. Now moving ahead, so feature selection was pretty simple. So we, for me, it was using basically on the model importance as well as the shapely values. And the model validation was done using k-fold cross-validation, so which I'll come to later. Yeah, so related to model building and evaluation, so I have included here basically 3 tree-based models which are random forest regressor, light GBM, and cat boost, which I tried for this particular raw data set. Okay, so for me, the best RMSE was provided by cat boost, which was a 10K fold. Okay. For cat boost, I do have the train and the test RMSE, which was actually in sync. So all the feature importances are recorded and being presented in the next slide. Apart from that, the outlet year features included actually boost the score to an extent. Okay. Now, my final model was actually based on two kind of, the ensemble of two different cat boost model based on two different kinds of data sources. Okay. Yeah, so this is the model evaluation and model feature importances that we have. So I have just presented here that what is the RMSE for light GBM and cat boost for different, K-fold strategies that I have used. Okay. So this is one thing. Then apart from that, yeah. So coming to model explainability. So main thing which we see around any of the data or any of the business outcomes, that we need to explain the model that we have created, because machine learning is totally a black box kind of model. Okay. If we can't explain it, we can't explain to the client, to the stakeholders. So this is one of the best actually packages which we can use to explain what features actually driving what kind of predictions. Okay, so that's why this is SHAP, which is actually a game theoretic approach. Okay. Now moving ahead, this particular slide actually, what I want to show you that how SHAP actually helping any of the SMEs or any of the product team or any of the data scientists to explain that, okay, what kind of predictions, what kind of features actually are hampering that particular sales. Okay, so if you see in the first image that, okay, we have the base value is 1907, okay, which is the train value, and the model output value is around 1700 something. So obviously we can see that the outlet ID, which is one of the features that we have present. So for that particular index, for that particular outlet 046, so that particular feature or item FC or item visibility, that is boosting to lower, to basically lower sales other than the actual one. Okay. So, and basically as stated that outlet 46 is decreasing the sales prediction. Okay. Whereas the outlet size and the location type actually increasing, it was trying to increase the sales prediction. So in terms of explainability, we can basically try to say that, okay, we can create one kind of a dashboard, okay, and we can try to explain that, okay, this particular for this outlet ID, for this item ID, okay. So there is something obviously which are actually affecting this kind of predictions. So that is one thing which actually SHAP is best to explain. So yeah, so basically now for this one, the main objective here is to understand the model with respect to the input features, okay. So we can target certain outlets and items in a single year to explain that which features are actually driving the predictions. Okay, coming to the next slide. So there are few results and recommendations which I would like to show. Okay, so for example, the complex. So there are certain complex nonlinear models which I have used, like the tree models. Apart from that, there are lasso ridge, which actually also gave a very good score. Okay, which I have tried using PyCaret package for it. So that is actually one thing which is we can use for deployment purposes. Otherwise, CatBoost is the best one, which is giving you actually a very good score. Okay, and the other one is obviously the model explainability part, which is really important in any of the driving presentations or anything, to understand the clients that what kind of data that we have. Apart from that, we can deep dive for outlet and item features based on the historical data as well. Okay. And yeah, and we can use third-party or in-house analytics, okay, which we can basically drive to, move on the sales and everything in terms of profitability. Now, I do have some recommendations, which are actually some of the business outcomes that I would like to show you. Okay. So first of all, for me, the making the models which are actually best explained are the, will give actually more understanding to the clients for sales and in terms of profitability, because they need to understand that which outlets are there, why are they underperforming, what are the important macroeconomic factors that are actually affecting there. Apart from that, considering the historical data, obviously dashboards using any of the tools we can use for analysis for dashboards. Then we have, there is one more thing which I kind of innovative thing. So I have created item IDs recommendations. Okay, so for different outlet IDs, we can basically try to recommend different item IDs, which are basically based on sales, and that can be used to increase your productivity or the profitability. Apart from that, model deployment and serving using Fast API is the best one to serve, right? Now, this is one of the analytics dashboard that I have created using Power BI. Okay, so this is something which will show you based on what number of sales, what outlet IDs are there. Now moving ahead, yeah, so this is one of the item-based recommendations. So I've used collaborative item-to-item filtering, which is used with k-nearest neighbors and matrix factorization method. Okay, so basically tell you that which kind of items are which closely related to what different items. So we can basically create one outlet or the outlet tier categories and basically tell that, okay, this item, if you try to sell here, obviously it will increase your productivity and everything. So, yeah, thank you.
So, Judy, any questions?
You said as final model you used CAD boost model.
Yeah, right.
And with two different data sources, so you created two models.
Right, so basically,
what are these data sources?
Yeah, so the data sources is actually one. So what I have done is that CAD boost actually, we all know that, so it works well on, the categorical variables, okay. So I used one of the data, so I created two pipelines, okay, for the same data set. One we have, I have included much different kind of features, some aggregation features, okay. And then I have the other pipeline which was including only just the categorical variables, okay. And basically creating those two particular models, those CAD boost models, and just taking an ensemble of both of those things will actually provide you the best. So basically for different, so it will actually, help us to, reduce the variance that each and every machine learning models actually try to give.
Interesting.
Anything?
Rajat, on one of the slides you mentioned that for outlet ID 18, in 2005, there were practically no sales. And in 2007, if you look at the sales figures, the sales from outlet ID 18 was second highest in number.
Correct.
Didn't that raise an alarm? And if it did,
yeah, obviously, that is kind of an anomaly which we actually see somewhere around the real time. So, for example, if we have a COVID scenario at around 2005 or 2000 at that particular outlet, so that outlet might be closed. Though it has a record number of sales in the previous years, but at that point of time, due to some economic factors or due to some company factors, obviously it has to be closed at that point of time. Therefore, it has no sales. But apart from that, as we have seen that there is a trend around following years. So in the next year, in 2007, obviously when the store has opened, it has a record number of sales because there was a demand, so there was a supply.
Okay, so my question is, you did take that into account while you were building it?
Yeah, obviously. So that's why I have taken the outlet year as kind of a categorical variable, which helps the CAD boost to, model it accordingly.
Any other?
Thank you.
Any other questions? Thanks. So now we'll break for lunch, and we should be back by 1:45. It's roughly half an hour for lunch, so that we can resume with the last few, not the least, of the presentations. So we have a lovely spread arranged.
The unique value proposition of the School of Management and Entrepreneurship at Shiv University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment, which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs so that our students emerge as theoretically grounded, practical problem solvers for the digital world. The unique value proposition of the School of Management and Entrepreneurship at Shiv Nadar University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs so that our students emerge as theoretically grounded, practical problem solvers for the digital world. Shiv Nadar University is a comprehensive, research-focused, student-centric university that is focused on student outcomes. And the School of Management and Entrepreneurship sits smack in the middle of that ecosystem. In machine learning, there is a concept of meta-learning, which basically means learning to learn. Much of our educational philosophy at the School of Management and Entrepreneurship at the Shiv Nadar University is to attempt to create a meta-learner among our graduates. There are two aspects of education we believe that is going to drive the future. One part of that education is going to be changing over time, such as tools, such as techniques. With the pace at which the digital economy is evolving, the rate of obsolescence of those tools and techniques is very, very fast. There are certain unchanging aspects of education, which is deeply rooted in the theories and the fundamentals and the first principles that are relatively unchanging. So this balance between the unchanging and the changing aspects of education is very much a guiding force of most of our programs at the School of Management and Entrepreneurship. And the blend is largely geared towards creating a student outcome wherein they become lifelong learners and they figure out how to navigate the environment to how to stay relevant and ahead of the curve as the most uncertain future unfolds. The COVID has changed the world fundamentally. The old models of education based upon rote learning, based upon use cases, based upon examination is now defunct. There is wide-ranging agreement that education needs to be re-examined, needs to be reimagined to create a leadership that would drive the future economy, which is going to be heavily driven by digital technology. So in our school, what I am attempting to do is to reimagine, reboot that curriculum and the model of business education, wherein this whole aspect of entrepreneurial trait with a clear focus on the digital technology takes the center stage of everything that students do here at the School of Management on Entrepreneurship. So at the School of Management on Entrepreneurship, we will be working with people who are invested in becoming leaders of the digital economy. The unique value proposition of the School of Management and Entrepreneurship at Shiv Nadar University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment, which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs so that our students emerge as theoretically grounded, practical problem solvers for the digital world. Shiv Nadar University is a comprehensive, research-focused, student-centric university that is focused on student outcomes. And the School of Management and Entrepreneurship sits smack in the middle of that ecosystem. In machine learning, there is a concept of meta-learning, which basically means learning to learn. Much of our educational philosophy at the School of Management and Entrepreneurship at the Shiv Nadar University is to attempt to create a meta-learner among our graduates. there are two aspects of education we believe that is going to drive the future. One part of that education is going to be changing over time, such as tools, such as techniques. With the pace at which the digital economy is evolving, the rate of obsolescence of those tools and techniques is very, very fast. There are certain unchanging aspects of education, which is deeply rooted in the theories and the fundamentals and the first principles that are relatively unchanging. So this balance between the unchanging and the changing aspects of education is very much a guiding force of most of our programs at the School of Management and Entrepreneurship. And the blend is largely geared towards creating a student outcome wherein they become lifelong learners and they figure out how to navigate the environment to how to stay relevant and ahead of the curve as the most uncertain future unfolds. The COVID has changed the world fundamentally. The old models of education based upon rote learning, based upon use cases, based upon examination is now defunct. There is wide-ranging agreement that education needs to be re-examined, needs to be reimagined to create a leadership that would drive the future economy, which is going to be heavily driven by digital technology. So in our school, what I am attempting to do is to reimagine, reboot that curriculum and the model of business education, wherein this whole aspect of entrepreneurial trait with a clear focus on the digital technology takes the center stage of everything that students do here at the School of Management and Entrepreneurship. So at the School of Management and Entrepreneurship, we will be working with people who are invested in becoming leaders of the digital economy. Nadar University, is being built on a few very important pillars. One of the pillars is multidisciplinarity. The second pillar is project-based learning, and the third piece is to be research-driven, right? So if you look at this trifecta, these three vertices of this triangle of multidisciplinarity, learning by doing or project-based learning and being research-driven, the data sciences course that you are about to launch into checks off on all of those three vertices. You probably have at your disposal the best of resources. We are quite happy to be partnering with Jigsaw Academy, who are very well reputed in the field of business analytics throughout the country, ranked #1 in the country by multiple ranking systems.
More and more, data has become so central in ways we live, things we do, decisions we take, that it's almost impossible to get around without that. And here, what we have done is we have assembled a program that brings all the necessary tools and thinks about how to apply in some contexts, right? And that's the beauty of this certificate program that has been designed especially for you guys.
Data science uses the best of multiple worlds, and it uses elements of math, stat, computer science, economics, natural sciences, fields like related to biology, like bioinformatics, genetics, genomics, as well as the modern nanoscience and nanotechnology, you name it. It's from a practical perspective. It will open up a wide variety of work opportunities for you in the industry as well as in the academics.
Shiv Nadar brings enormous amounts of intellectual firepower, which complements what we do at Jigsaw, and I think together it's just amazing. And I've talked to these guys before. They're just insane amounts of intellect there, and we try to bring in the industry piece and the applications piece and create something. We have tried to create something which should be extremely useful for all of you guys. And as Jadip mentioned, not just for your jobs or your resumes, but for real life.
So I wish you all the best on that. And I'm also wanted to share with you that we are expecting full commitment from your side, because from our side, we promise you full commitment. The unique value proposition of the School of Management and Entrepreneurship at Shiv Nadar University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment, which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs, so that our students emerge as theoretically grounded, practical problem solvers for the digital world. Shiv Nadar University is a comprehensive, research-focused, student-centric university that is focused on student outcomes. And the School of Management and Entrepreneurship sits smack in the middle of that ecosystem. In machine learning, there is a concept of meta-learning, which basically means learning to learn. Much of our educational philosophy at the School of Management and Entrepreneurship at the Shiv Nadar University is to attempt to create a meta-learner among our graduates. There are two aspects of education we believe that is going to drive the future. One part of that education is going to be changing over time, such as tools, such as techniques. With the pace at which the digital economy is evolving, the rate of obsolescence of those tools and techniques is very, very fast. There are certain unchanging aspects of education, which is deeply rooted in the theories and the fundamentals and the first principles that are relatively unchanging. So this balance between the unchanging and the changing aspects of education is very much a guiding force of most of our programs at the School of Management and Entrepreneurship. And the blend is largely geared towards creating a student outcome wherein they become lifelong learners and they figure out how to navigate the environment to how to stay relevant and ahead of the curve as the most uncertain future unfolds. The COVID has changed the world fundamentally. The old models of education based upon rote learning, based upon use cases, based upon examination is now defunct. There is wide-ranging agreement that education needs to be re-examined, needs to be reimagined to create a leadership that would drive the future economy, which is going to be heavily driven by digital technology. So in our school, what I am attempting to do is to reimagine, reboot that curriculum and the model of business education, wherein this whole aspect of entrepreneurial trait with a clear focus on the digital technology takes the center stage of everything that students do here at the School of Management on Entrepreneurship. So at the School of Management and Entrepreneurship, we will be working with people who are invested in becoming leaders of the digital economy. Nadar University, is being built on a few very important pillars. One of the pillars is multidisciplinarity. The second pillar is project-based learning, and the third piece is to be research-driven, right? So if you look at this trifecta, these three vertices of this triangle,
what we do at Jigsaw, and I think together it's just amazing. I've talked to these guys before. They're just insane amounts of intellect there, and we try to bring in the industry piece and the applications piece and create something. We have tried to create something which should be extremely useful for all of you guys. And as Jadip mentioned, not just for your jobs or your resumes, but for real life.
So I wish you all the best on that. And I'm also wanted to share with you that we are expecting full commitment from your side, because from our side, we promise you full commitment. The unique value proposition of the School of Management and Entrepreneurship at Shiv Nadar University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment, which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs, so that our students emerge as theoretically grounded, practical problem solvers for the digital world. Shiv Nadar University is a comprehensive, research-focused, student-centric university that is focused on student outcomes. And the School of Management and Entrepreneurship sits smack in the middle of that ecosystem. In machine learning, there is a concept of meta-learning, which basically means learning to learn. Much of our educational philosophy at the School of Management and Entrepreneurship at the Shiv Nadar University is to attempt to create a meta-learner among our graduates. There are two aspects of education we believe that is going to drive the future. One part of that education is going to be changing over time, such as tools, such as techniques. With the pace at which the digital economy is evolving, the rate of obsolescence of those tools and techniques is very, very fast. There are certain unchanging aspects of education, which is deeply rooted in the theories and the fundamentals and the first principles that are relatively unchanging. So this balance between the unchanging and the changing aspects of education is very much a guiding force of most of our programs at the School of Management and Entrepreneurship. And the blend is largely geared towards creating a student outcome wherein they become lifelong learners and they figure out how to navigate the environment to how to stay relevant and ahead of the curve as the most uncertain future unfolds. The COVID has changed the world fundamentally. The old models of education based upon rote learning, based upon use cases, based upon examination is now defunct. There is wide-ranging agreement that education needs to be re-examined, needs to be reimagined, to create a leadership that would drive the future economy, which is going to be heavily driven by digital technology. So in our school, what I am attempting to do is to reimagine, reboot that curriculum and the model of business education, wherein this whole aspect of entrepreneurial trait with a clear focus on the digital technology takes the center stage of everything that students do here at the School of Management on Entrepreneurship. So at the School of Management on Entrepreneurship, we will be working with people who are invested in becoming leaders of the digital economy. Nadar University, is being built on a few very important pillars. One of the pillars is multidisciplinarity. The second pillar is project-based learning, and the third piece is to be research-driven, right? So if you look at this trifecta, these three vertices of this triangle of multidisciplinarity, learning by doing or project-based learning and being research-driven, the data sciences course that you are about to launch into checks off on all of those three vertices. You probably have at your disposal the best of resources. We are quite happy to be partnering with Jigsaw Academy, who are very well reputed in the field of business analytics throughout the country, ranked #1 in the country by multiple ranking systems.
More and more, data has become so central in ways we live, things we do, decisions we take, that it's almost impossible to get around without that. And here, what we have done is we have assembled a program that brings all the necessary tools and thinks about how to apply in some contexts, right? And that's the beauty of this certificate program that has been designed especially for you guys.
Data science uses the best of multiple worlds, and it uses elements of math, stat, computer science, economics, natural sciences, fields like related to biology, like bioinformatics, genetics, genomics, as well as the modern nanoscience and nanotechnology, you name it. It's from a practical perspective, it will open up a wide variety of work opportunities for you in the industry as well as in the academics.
Shiv Nadar brings enormous amounts of intellectual firepower, which complements what we do at Jigsaw. And I think together it's just amazing. I've talked to these guys before. They're just insane amounts of intellect there. And we try to bring in the industry piece and the applications piece and create something. We have tried to create something which should be extremely useful for all of you guys. And as Jadip mentioned, not just for your jobs or your resumes, but for real life.
So I wish you all the best on that. And I'm also wanted to share with you that we are expecting full commitment from your side, because from our side, we promise you full commitment. The unique value proposition of the School of Management and Entrepreneurship at Shiv Nadar University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment, which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs so that our students emerge as theoretically grounded, practical problem solvers for the digital world. Shiv Nadar University is a comprehensive, research-focused, student-centric university that is focused on student outcomes. And the School of Management and Entrepreneurship sits smack in the middle of that ecosystem. In machine learning, there is a concept of meta-learning, which basically means learning to learn. Much of our educational philosophy at the School of Management and Entrepreneurship at the Shiv Nadar University is to attempt to create a meta-learner among our graduates. There are two aspects of education we believe that is going to drive the future. One part of that education is going to be changing over time, such as tools, such as techniques. With the pace at which the digital economy is evolving, the rate of obsolescence of those tools and techniques is very, very fast. There are certain unchanging aspects of education, which is deeply rooted in the theories and the fundamentals and the first principles that are relatively unchanging. So this balance between the unchanging and the changing aspects of education is very much a guiding force of most of our programs at the School of Management and Entrepreneurship. And the blend is largely geared towards creating a student outcome wherein they become lifelong learners and they figure out how to navigate the environment to how to stay relevant and ahead of the curve as the most uncertain future unfolds. The COVID has changed the world fundamentally. The old models of education based upon rote learning, based upon use cases, based upon examination, is now defunct. There is wide-ranging agreement that education needs to be re-examined, needs to be reimagined to create a leadership that would drive the future economy, which is going to be heavily driven by digital technology. So in our school, what I am attempting to do is to reimagine, reboot that curriculum and the model of business education, wherein this whole aspect of entrepreneurial trait with a clear focus on the digital technology takes the center stage of everything that students do here at the School of Management and Entrepreneurship. So at the School of Management and Entrepreneurship, we will be working with people who are invested in becoming leaders of the digital economy.
Shiv Nadar University, is being built on a few very important pillars. One of the pillars is multidisciplinarity. The second pillar is project-based learning, and the third piece is to be research-driven, right? So if you look at this trifecta, these three vertices of this triangle of multidisciplinarity, learning by doing or project-based learning and being research-driven, the data sciences course that you are about to launch into checks off on all of those three vertices. You probably have at your disposal the best of resources. We are quite happy to be partnering with Jigsaw Academy, who are very well reputed in the field of business analytics throughout the country, ranked #1 in the country by multiple ranking systems.
More and more, data has become so central in ways we live, things we do, decisions we take, that it's almost impossible to get around without that. And here, what we have done is we have assembled a program that brings all the necessary tools and things about how to apply in some contexts, right? And that's the beauty of this certificate program that has been designed especially for you guys.
Data science uses the best of multiple worlds, and it uses elements of math, stat, computer science, economics, natural sciences, fields like related to biology, like bioinformatics, genetics, genomics, as well as the modern nanoscience and nanotechnology, you name it. It's from a practical perspective. It will open up a wide variety of work opportunities for you in the industry as well as in the academics.
Shiv Nadar brings enormous amounts of intellectual firepower, which complements what we do at Jigsaw. And I think together it's just amazing. I've talked to these guys before. They're just insane amounts of intellect there. And we try to bring in the industry piece and the applications piece and create something. We have tried to create something which should be extremely useful for all of you guys. And as Jadip mentioned, not just for your jobs or your resumes, but for real life.
So I wish you all the best on that. And I'm also wanted to share with you that we are expecting full commitment from your side, because from our side, we promise you full commitment. The unique value proposition of the School of Management and Entrepreneurship at Shiv Nadar University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment, which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs, so that our students emerge as theoretically grounded, practical problem solvers for the digital world.
Shiv Nadar University is a comprehensive, research-focused, student-centric university that is focused on student outcomes. And the School of Management and Entrepreneurship sits smack in the middle of that ecosystem. In machine learning, there is a concept of meta-learning, which basically means learning to learn. Much of our educational philosophy at the School of Management and Entrepreneurship at the Shiv Nadar University is to attempt to create a meta-learner among our graduates. There are two aspects of education we believe that is going to drive the future. One part of that education is going to be changing over time, such as tools, such as techniques. With the pace at which the digital economy is evolving, the rate of obsolescence of those tools and techniques is very, very fast. There are certain unchanging aspects of education, which is deeply rooted in the theories and the fundamentals and the first principles that are relatively unchanging. So this balance between the unchanging and the changing aspects of education is very much a guiding force of most of our programs at the School of Management and Entrepreneurship. And the blend is largely geared towards creating a student outcome wherein they become lifelong learners and they figure out how to navigate the environment to how to stay relevant and ahead of the curve as the most uncertain future unfolds. The COVID has changed the world fundamentally. The old models of education based upon rote learning, based upon use cases, based upon examination is now defunct. There is wide-ranging agreement that education needs to be re-examined, needs to be reimagined to create a leadership that would drive the future economy, which is going to be heavily driven by technology.
Can we have every other seat, please?
So in our school,
we're ready to commence.
What I am attempting to do
All right, so I hope, I believe, some of you did tell me that you had a fantastic lunch and a good dessert. And now, just to make things a little more interesting, so we have with us the person at the top of the value chain at the university. So let me take a moment to talk about Shikhar Malhotra, the director of HCL Corporation, the Vice Chairman and CEO of HCL Healthcare, the Pro-Chancellor of Shiv Nadar University, the Founder CEO of Shiv Nadar School, and Trustee, Shiv Nadar Foundation, and the Habitats Trust. Shikhar Malhotra is a Director and Board Member of HCL Corporation, the holding company for HCL's operating companies. He's also on the board of HCL Tech, with a 10.1 billion global technology firm value, with over 169,000 professionals operating from across 50 countries. Shikhar serves as the Vice Chairman and CEO of HCL Healthcare, one of India's largest corporate health solutions firm, providing end-to-end healthcare solutions with a vision to make corporate India a healthier place. In September 2018, Shikhar took over the role of the Pro-Chancellor of Shiv Nadar University, which is India's youngest university to be chosen as an institution of eminence by the Government of India. That's an interesting fact. As a trustee, Shikhar plays multiple roles at the Shiv Nadar Foundation, including shaping its vision of nation building through transformational leadership. Shikhar is the founding CEO of Shiv Nadar Schools, having led them to become one of the most coveted schools in the National Capital Region of Delhi and consistently recognized among the top schools in the country. Passionate about wildlife and conservation, Shikhar co-founded the Habitats Trust in 2018 with his wife, Roshni Nadar Malhotra. The trust is empowering on-ground conservationists to achieve its vision of securing India's natural habitats and their indigenous species. Shikhar comes from an entrepreneurial family raised in Kuwait. His early lessons as an entrepreneur were learnt at his family business and were later sharpened at Babson College in the US with a specialization in entrepreneurship. So with this, may I invite the savvy and debonair Shikhar Malhotra on stage, please. And may I also invite the jury members to kindly join us on stage, please. And Dr. Banerjee, please. Yes. So, have the mementos. Mementos. So, yeah, let's all line up in the most interesting way possible. And yeah, he sure knows how to make the frame look good. So anyway, can I have the memento for Manoj Madhusudanan? And
No, you have to tell Shikhar what he's supposed to do. Yeah.
You're supposed to hand it over.
I'll just say a few words. Basically, we were going to get Shikhar to give the final awards, but I believe we are running a couple of presentations late. But he has to be in another meeting in Delhi in the evening. So we quickly sort of did this improvisation to get Shikhar to give away the mementos to the jury. So Shikhar, would you want to say a few words, or I think that'll be nice. Just.
I was told about this event actually this morning, so I know a little bit about it, but over lunch I was introduced to the nature of the event and the competition, and actually I was very intrigued, so I have asked to Vivek to please share that with me as well, because I'm very intrigued in the way, in the world and environment we live in, how you're approaching these data set challenges and finding solutions, because that's something I'm doing in my organization and in my business on a day-to-day basis all the time. And I'm learning a great deal, actually, as well. As you know, that it's a very evolving field. Also, I think my introduction was embarrassingly long, okay? I don't think even my wife knows half those things, right? But, thank you for that introduction. And I just want to welcome you all to Shiv Nadar University. I hope you've had an opportunity to walk around, enjoy the campus, not be confined just to this room, right? Although I know that this is where the energy and the excitement is. But post the event, stretch your legs, walk around, get a feel of the campus. There is enough to do. I'm sure Vivek and Rajat and everyone else actually over here, Aaron, would be happy to show you around. Thank you very much.
Thanks, Shikhar. So,
so this would be the memento for Manoj Madhusudanan.
Oh, yeah.
And now the next one for the elegant Swati Jain.
Thank you for your time.
And this one would be for Megha. And this one would be for Nish Agarwal. And can we have one more photograph with all the jury members and Shikhar and Dr. Banerjee? And I will still ask you to hold your patience while I'll invite all 10 finalists to kindly join us on stage. All of you, please.
Good idea.
Because as far as we are concerned, all of you are winners already. So we'll start with the Sir, can you bring all the certificates? Give them all. Just bring them all this side. So we'll start with the certificate of participation for Vivek Kumar. Vivek? And can I have the next certificate? This would be one for Akash Gupta. Next we have Arpita Sagar. And Rahul Pridnekar. Next is Mukul Sharma. And Rupesh Prasad. Then Rajat Ranjan. And Indrashish Das. Yash Khandelwal. And finally we have Jagrut Pradeep Lalwani. And just one group photograph with everyone on stage. So just whatever is the best way to capture the moment. We should have had a bigger stage, I guess. Thanks, everyone, and especially thanks to Shikha for taking time out. And now we will proceed to the final leg of the presentations with the next participant. May I have Indrashish Das? So Indrashish Das is a product analyst at High Radius Technologies. He's the founder of ScleroLearner and has substantial experience with machine learning and Python coding, among many other tools. So he's just getting sorted, audio-wise. All the best, Indrashish.
Hello.
Can we have the timer on? You can take a look at the projection there as well if you want.
Thank you. Thanks a lot for a quick introduction, Rajat. A good afternoon to the respected jury members, my fellow participants, and the organizers of this wonderful hackathon. So, in the interest of time, I'll be quickly starting with what I have to present today. So, as far as the agenda is concerned, there are primarily 5 sections to my presentation, where the first 3 sections pertain to the technicalities of how I came down to the best model, and the last 2 pertain to how does business work, and I would also want to give a taste of product management, like how does it combine. So to start off with the data understanding part, this is not working, excuse me. Okay, so to start off with the data understanding part, there were somewhere around 87,864 records and primarily 12 fields. These 12 fields were further divided into item-related characteristics and outlet-related characteristics, and the last set consisted of only 1 field, which related to the output label that we need to predict. Now, even before I started with feature engineering, I had to understand what these field types are. So that is where the number of unique values and the field description helped me to double down on the field type. That further helped me to do the feature engineering. Now, visualizing the continuous fields, there were primarily 4 continuous fields in the data set, where item weight, item visualization, and item MRP showed a distribution which was like all over the place, but sales showed a rightly skewed distribution. Again, the most heartbreaking point was to see that there was no correlation among these fields, and yeah, that is what I had observed. Now, one interesting point is, what does negative sales imply, right? If we think logically, the sales function would look something like, it would give us a 0 if no sales happened, else it would give us some value ranging between 0 to infinity in case some sales happened. But there were some 397 records ranging from minus 1229 to minus 0.022, which showed a negative sales. Now, negative sales could happen because of 2 things. Either there could be certain stock of product that was unsold, or it could also exist due to this cumulative sum of the amount that led to the stock that was unsold. For the categorical fields, I didn't observe much observations because the categories were mostly around the distribution of the original output label. But there were 2 interesting points that I had to discuss. One was understanding the outlets in the data set. So if you see, the same outlets had various establishment years, and that intrigued me a lot. But to explain this concept, I would like to take an example. So outlet IDs are nothing but, for example, big supermarket stores like Big Bazaar, Spencer's, or Big Market. And how could outlet year be different is that, let's say if one outlet, the same company is opening different stores in different locations or with different characteristics like outlet size or outlet type, then in such cases the establishment could be different because it might have opened in a different point of time. Another intriguing observation that I observed and was very shocking to me was that for the same item ID that existed in the same outlet ID, outlet year, outlet size, outlet location, and outlet type, the item type was changing. Now, something that is tagged to be a health and hygiene product can never be a baking good, right? So because of this, I was pretty much sure that the RMSE of the model would be high, right? The RMSE of the sales field. So this is a common phenomenon that I observed in the data set. Now, moving towards the data preparation part, even before splitting the data set, I randomly shuffled the data set so that the distribution of the data is pretty much throughout the data set. And post that, what I did is I went with dividing the data as 70% training, 15% validation, and 15% test. Now, to validate if all the data sets are same, I plotted the probability distribution of the sales field. Now, because it's identical, it proves that my hypothesis is true. Moving towards feature engineering, I applied some auto feature engineering techniques where I built a master feature generator, which primarily did 3 things. It did target encoding, it did ratio-based features, and label encoding. For target encoding, it took the combination of categorical columns, continuous columns, and aggregation points like mean, median, min, and max. Ratio-based features was like percentage of frequency of each category, and based on that, I came down to somewhere around 208 features in this case. Apart from that, I also tried to extract the characters from the outlet ID field, which was the alphanumerical field. That didn't work well. Apart from that, I also tried to apply certain transformations like box-Cox transformations or exponential transformations. Also, I tried to apply capping the upper limit above the outlier and capping the lower limit where the sales were going in negative numbers. I also tried k-means clustering to group certain similar item IDs to reduce the number of item IDs. Further, although we know that there are 3 types of feature selection methods like filter methods, wrapper methods, and embedded methods, I used a combination of feature importance along with my own way, which tells me that how a feature is impacting my model's performance. So that is how I did feature selection. Further, moving towards the model building and results, I saw that gradient boosting regressor out of all these methods, right? You have linear methods, you have kernel-based methods, you have clustering methods, and so on. You have ensembling and boosting as well, where I saw that gradient boosting was working the best, and that is why I went with using the same algorithm for making it better with time. Further, why gradient boosting regressor? Linear algorithms tend to work for data which has a good correlation. Here I didn't see that. Clustering works on large data sets. SVMs tend to become slower for large number of observations. Decision trees are expected to overfit, and that is why boosting based algorithms were the key here to help me build the best model. Now going towards applying new approaches, as you can see for the 6th serial number, I could see that the best model that I could come up with was appending the test set along with the validation set with the training set, which means it was the complete training data which was provided to us. It gave me a leaderboard RMSE of 1270.977, right? But apart from that, I also reduced from 208 features to 122 features by eliminating features where the feature importance was 0. Further, I used my own method of seeing the feature impact on the model's performance. That helped me a lot. Apart from that, I tried hyperparameter tuning, which did not work well. It was increasing the leaderboard RMSE. I also tried applying Scalar Learner, which is a package that I have deployed. So it works on the concepts of using residual errors from the previous model, tries to build another model by learning that, but that was highly overfitting the model. That didn't work as well. Apart from that, transform target regressor and logarithmic transformation also didn't work well, so didn't use it. And that is where the best model that I had was using the complete training data set on the and using gradient boosting regressor to build a model with the default hyperparameters. Also, you can see here that most of the features are based on target encoding. I was pretty much sure that because most of the fields are categorical in nature, target encoding would work best, and you have 20 out of the 23 features to be target encoding. And that is where I use the complete training data set to build the model. Further, to visualize the error distribution, although the validation set and the testing set were appended to the training data, I still saw the error distribution, which was like right skewed, and it gave me some relief because it was right skewed in nature, which meant that the errors are towards the left hand side of the graph and it's lesser in nature, right? That was a good thing that happened. Now moving towards the business understanding. Working as a product analyst with high radius always helps me to get into the crux of the business, and that is where thinking by first principles and coming to the elemental level of the problem, it's very important for us to understand what is sales. So Google and Investopedia gave me two definitions, right? They are very good at giving us information and definitions, but what I could comprehend and conclude from these definitions was that sales is all about selling goods and services, which implies generating revenue. Further, there are three types of business models, like it could be a B2B, B2C or C2C case. So each of these have separate examples. For example, Sun Pharma selling medicines to PharmEasy, like it's a business-to-business partnership. Further, PharmEasy selling medicines to its customers, going to their homes and selling these medicines is like a business to customer. While retail, you going to retail shops and buying medicines is like a customer to customer case. Now coming to why is sales necessary, there could be three primary reasons why sales is necessary. First is building loyalty. Some people are very much focused towards getting referential clients and they want to build their branch. That is where building loyalty is important. Generating revenue. Some people are just focused about generating revenue and increasing the profit maximization. But there are also some type of people who are very much keen and interested in solving real life problems. Primary and classical example, Phil Knight and Bill Bowman from Nike, who made the shoes which were given to marathon runners, right? They made shoes for the marathon runners. That's a classical example we have. Now, what is the real life application of this use case? So let's just think, if we didn't have the power of AI and machine learning, what would happen? There's a sales analyst, goes and exports data from some CRM or ERP, loads it in Google Sheets or Microsoft Excel, and uses the concept of averaging previous N months per product per outlet to come to the average sales. But in this process, you might not be able to incorporate the seasonal and cyclical patterns, right? And on top of that, this is extremely manual and takes lots of efforts. The classical example here I would want to take is the sales of umbrella. If you want to capture or predict the sales of umbrella in the month of January, right? You might go and use this method because December, November and October doesn't have much sales of umbrella, right? The primary requirement of an umbrella comes in the month of May, or it comes in the month of June or July when it's harsh summers or harsh rain or precipitation happens a lot. So that is where, in similar way, if you want to calculate the sales of the month of May, you'll not be able to, just average out for February, March and April. That won't make sense, right? You'll not be able to incorporate seasonal patterns. But and this is where the ML-based sales prediction helps us a lot. Why? Because the historical data that we feed into the model will help us a lot to incorporate seasonal and cyclical trends in the model. That further helps us to predict better with time. Now, ML changing lives. How is ML changing lives here? So sales predictions act as an input to 3 primary stakeholders. First could be sales analyst. A sales analyst could know beforehand that what is going to be the sales for that month or quarter or year, right? That is where, in case if the person sees or the sales analyst sees that the sales are going to be low, they can try to apply some improvement techniques to better that. Apart from that, it could really help inventory management teams to go with a quality market equilibrium by planning the best inventory management. And obviously that would lead to a high profit maximization. The third set of stakeholders would be the board of directors and office of the CEO. It would give them numbers to compare, like planned versus actual sales and current versus expected sales. And also, the most important thing for an organization is treasury management. That is where it would help a lot to these organizations to go and do receivables forecasting and do treasury management. So they can actually calculate or predict the incoming cash in their organization. Now, apart from all the business, the other most important thing in the present day is machine learning operations. Why is it important? It's the most difficult job in the present day, even more difficult than building a model, right? So the first half of the cycle shows that how we are building the best model and deploying it, right? Deployment could be easily done using AWS S3, Lambda, SageMaker and all these things, right, in the production system. But monitoring is a very important process here. The reason being, let's say if you're not monitoring the actual sales, right, and you are not being able to calculate as to how your model is performing, then that might not be beneficial for you. The reason being, if your model is not performing well, it might give you incorrect results. And that is where actuals need to be calculated within a regular interval of time, and it has to be fed back as a feedback to the model. So that is how it works.
Sorry, I guess you're about time. Can we have a quick look at the recommendations of this?
Sorry?
Can you jump onto the recommendation slide if you have any?
These were the recommendations.
Okay.
So ML operations.
We have the last 1 minute for you.
Yeah. So with that, I believe that's an end to my presentation. Yeah.
Great. So just wrapped in the nick of time. So now, jury, all yours. Any questions?
Indrashish, I am the sales head for this retail organization. Very well presented, but what do I do next?
What do I
do next? With your analysis of the data and all of your presentation, what should I do next? As the sales head of this organization, what are your top 2-3 suggestions to me?
So my top 2-3 suggestions are that whenever you are using an ML-based approach to, predict sales.
I don't know if I should be using it or not. I don't know if I should actually be using it.
So stakeholders are not data scientists, right? We are business.
Correct.
So we wouldn't be able to relate any technical, jargons around ML or anything else.
Mm-hmm. So my first recommendation would be to define business metrics around the model's performance. The reason being the business, because see, what matters at the end of the day is value out of the use case, right? So that is where it's really important to understand if the use case or the model is actually giving me value or not. So that's one recommendation that I have. Apart from that, consuming the sales in a very proactive manner is very important. Like once you know, let's say my sales are going to be lesser or it's going to be poor. So what do you do next? You think of marketing strategies to go ahead and improve your sales, right? If the sales are going to be low.
So in the sheet, let me make an attempt. With this data, right, this 87,000 rows and the analysis you have done, if you had to advise the sales director or the CEO, what would you say for this company, for Megamart?
Okay. So the best thing that I can say to my CEO is going forward that we obviously need to improve our sales. Now, how do we boost or improve our sales is by, again, it's all about thinking of new ways to, market it best and, come down to the best sales. That's it. Yeah, that's it.
Thank you so much. Well, like Confucius, if you can convince them, you can confuse them. Query? Yeah, please.
Indrashish, you mentioned that the RMSE of the gradient boosting regressor was only slightly better than that of linear regressor. So, but at the same time, the explainability of the model would fall down drastically. In a linear regressor, which I'm assuming would be a time series forecasting model, you can explain a lot of things, what kind of seasonal patterns were observed, what kind of relationship between the variables was observed. Do you think the slight additional performance lift that was obtained in the model, is it worth sacrificing the explainability and going for the gradient boosting regressor, or should Megamart stick with the linear regressor?
Okay, so to answer that question, what I believe is, if it's just the slightest of the change, right, we should always go with a way more explainable model. This comes from the concept that, for example, let's say you have 10 features, 8 features are giving you, let's say 89% accuracy, and the last 2 features are giving you an additional of 0.2 or 0.3%. So it might not make sense adding them to the model because it's increasing its complexity, right? So that is where, in such a case, I agree to you, we should go with a linear regressor.
I think one more query.
Question about the
Scaro learner, yeah.
What was the origin of that? How did you go about creating that?
Okay, so how I went towards creating that is, actually we have an use case of predicting the payment date, right? Delay on invoices in our organization. So this is a very famous use case we have. So so what I had observed was that we were not able to achieve good RMSE, right? We were not able to achieve a lower RMSE, and that was the primary motivation behind building this library, that is Scaro Learner. So Scaro Learner actually tackles both. It tackles regression-based use cases as well. It also tackles classification-based use cases as well. For regression, it takes the error residuals and the same features, right, to build another model so that it can learn the errors. While for classification, it usually tries to build an error matrix, right? A combination of classes produces that error matrix, and that is what is used to predict for the classification use cases. That is how I came with this. I recently launched it. It was, I believe, back in June 2021 when I launched it. Most welcome.
Thank you, Indrashish, and all the best with your new platform launch. And let me also just take time out to acknowledge and welcome Dr. Sandeep Sen, the Dean of School of Engineering, who joined us. We're really glad to have you here. And moving on, we have the next finalist, which is Yash Khandelwal. So Yash, by the way, he's the youngest participant here. So he's a student, Birla Institute of Technology, Ranchi, and Yash has secured decent ranks in many hackathons. In fact, the first rank in Data Science Summit 2021. He also completed a research internship at IIT Hyderabad and was successful in writing a research paper that has been accepted for the IIIE IndyCon Conference 2021. So, all over to you.
So a very good afternoon to the honorable judges and everyone present here. I'm Yash Khandelwal. I'm a third-year student pursuing Integrated Masters of Science in Mathematics and Computing from BIT Mesra. So starting with the problem statement, in market, sales are vital to its long-term sustainability. Sustained growth in sales is the only key to survival in the market. So the problem statement revolves around the idea of sustaining the sales using machine learning and data science. With this, I would like to begin my presentation. So let's have a look at the data. The training data had total 87,864 observations with 12 features, out of which 7 were categorical and 5 were continuous. So each observation in the data tells something about an item or a product of the Megamart. And the target feature in the data is the sales. The test data has total 37,656 observations. Now looking at the key insights from the data. The highest number of observations in the data are from small outlets from Tier 1 cities, while the least number of observations are from large outlets from Tier 2 cities. Now talking about the distribution of the target feature, which is sales, the sales has a positively skewed distribution, which means the outliers are to the right of the distribution. Now let's see the relationship between the sales and the item MRP. So as the scatter plot shows, there is no as such a linear relationship between the MRP and the sales, which indicates that customers look for various other factors other than the price before making the purchase. Looking at some more insights, items falling under baking goods and fruits and vegetables have the highest count in the Megamart, as you can see from this count plot. The next visualization shows the visibility of different items in the Megamart. So the highest average visibility, item visibility in the Megamart is of soft drinks, while the least average visibility is of hard drinks. Going to the last insight from the data, which tells the average sales of all the items. So the average sales of all the items is almost equal, as you can see from this pie chart. But if we say then overall the average sales of breads is the highest. And I have used median as the average here, since we know that there are outliers which can influence the mean average. So I've used median as the average here. Now coming to the data preparation part, which involves cleaning the data and preparing the data. So fortunately, there were no null or missing values in the data. Talking about the outliers, so I found outliers using interquartile range method in the sales feature. So total 2,378 observations, which is 2.7% of the total sales data, are the outliers. So these outliers are probably not due to data entry, but they may contain some useful information about unusually high or low sales of some items in the Megamart. So I haven't dropped these outliers. Next part is categorical encoding, which involves converting the text data into a continuous form so that this information can be used by the ML model. So for the features with no order relationship, I have used the one-hot encoding method. For example, features like outlet ID, item type, outlet year, outlet type, I've used one-hot encoding. And in fact, the outlet year is a continuous feature, but I have considered it as a categorical feature here. So for the features with some order relationship, I have used ordinal encoding. The features like outlet size, outlet location type, item fact content. For example, if we see, let's say, outlet location type. So here, the values like Tier 1, Tier 2, Tier 3 are present. So here, Tier 1 is greater than Tier 2, which is greater than Tier 3. So due to this order relationship, I have used the ordinal encoding method. Now, some of the new features that I have created from the data are given in this slide. The first is years from the present. It is calculated by finding the difference between the present year and the outlet year. And it tells that how many years have passed since the establishment of that outlet. The next is item ID type. So for creating this feature, I extracted the first 3-letter word from each item IDs, since it may contain some useful information such as brand of item, some manufacturer detail. Now since this is a text data, I had to encode it, so I have used ordinal encoding based on item MRP, which means that the item ID types with high item MRP have a greater order than that of the item ID types with lower MRP. So now talking about the feature selection techniques, I have used permutation feature importance and XGBoost importance for feature selection, but however, both gave an increase in the RMSE of the baseline model. We'll be looking at the modeling process in more detail in the next slide. So before I discuss the experimental results that are present in this table, I would like to discuss few notes for the table. So here experiments are carried out sequentially, meaning the experiment number 1 is the first experiment. Experiment number 5 is the final experiment. The metric used here is root mean squared error, and the score here represents mean cross-validation RMSE with folds equals to 5 on training data. The test score represents the RMSE on the test data as reflected by the machine hack platform leaderboard, private leaderboard. So starting with the experiment 1, to create the baseline model, I evaluated various regularization regression methods and ensemble methods, and you can see the details of the from the first experiment. So the best performing model from it is an XGBoost. And in this experiment, I didn't perform any feature engineering, feature selection, or any hyperparameter tuning. In the next experiment, as I performed the feature engineering, which I described in my previous slide, like what new features I created. So you can see that the best performing model is XGBoost. It has a score lower than the previous experiment, but still it has the test score is higher than the previous experiment. In the next experiment, I created an ensemble stacking model. To create, you can see this, that it has the least score and test score from in all the previous experiments. So to create this optimal ensemble stacking model, I used the 4 models from experiment number 2, which are XGBoost, ridge regression, lasso regression, and light GBM. And you can see the experiment 2 results in experiment 3 box itself. And I also created a weighted average ensemble model of these 4 models, but the score and test score were both higher than the stacking ensemble model. In the next experiment, I performed feature engineering and feature selection. I've already discussed what techniques I have used for feature selection methods. So the score and test score are both higher than our previous experiment. In the last experiment, I performed feature engineering and hyperparameter tuning. These are the details of hyperparameter tuning for my best models. You can see that for light GBM and ridge and lasso, for which I use grid search method, the scores is actually improved. That means the RMSE is actually dropped. But for XGBoost, for which I have used Bayesian optimization, my target actually was to optimize many hyperparameters, hence I used Bayesian optimization technique. So the score is higher than the previous XGBoost. So these 4 hyperparameter optimized models, I used and created a weighted average ensemble model. It has a score that is least of all the experiments, but it still has a test score which is higher than the 3rd experiment. Now since the 3rd experiment is performing the best on the test data, I've used it as my final model. Let's look at it in more detail. This is the architecture of my final model. I've used linear regression as the meta learner here. So describing the algorithm during training, each model present in this ensemble stack are trained to predict the sales, while the meta learner will be trained to best combine their predictions. And during inference, each model in the ensemble will make the predictions, and the meta learner will input these predictions and make the final predictions. So this ensemble stack model made better predictions and achieved better performance than any of these single contributing model by harnessing their capabilities of these all individual best performing models. Now we'll look at some results and few recommendations from my side. So these are the business outcomes. So to expect some business outcomes from the model, a process needs to be followed. The first step of which is predicting the sales. Once we have got our ML model trained on the training data, we can take the test data and make our predictions. Now we analyze these data attributes, interpret the predictions, and make the changes in the respective attributes with the aim of increasing the sales. Now we repeat the first and second step until we find optimal attribute values that can be implemented on the business model. The first business outcome is improved product quality. So this can be done by improving the quality of items that are repeatedly giving low sales. So, so we can identify a few items or type of items, certain item types that are giving low sales, and try to improve the product quality on the business model itself. The second is business expansion. To expect this outcome, we can find the best combination of outlet location type, outlet type and size to establish new outlets. The third is increased customer base. So, so if we have obtained the previous two outcomes, then we can expect that our customer base which will actually grow. The next is improved customer service. This can be done by increasing the visibility of items that are in demand. And the second is improving the customer service of outlets that are giving low sales. The next is optimized revenue. So this can be done by removing the unprofitable items and adjusting item MRP. So now if we have gained the previous 5 business outcomes, then we can expect that our sales will get sustainable and will have a steady growth. Now here are some real-world impacts that I want to tell. The first is, if there is availability and improved quality of products, then the real-world impact would be more customers would be visiting the Mega Mart to make the purchase. The second is improved customer service. So the impact would be customers would have an easy and enjoyable experience in shopping that would actually help the outlets to retain customers and grow sales. The third is opening Mega Mart outlets at new locations. So the impact would be the new customers would be attracted. There will be an increase in the market influence. The last is revenue optimization. So the impact would be increase in revenue generation and profit margin. Now the final part, which is for the deployment of the models. So since the stacking ensemble model has given the best performance on the RMSE metric, it can be used for the deployment. Along with it, SHAP, it can be used for interpreting the performance of the boosting models, XGBoost and LGBM that are a part of my ensemble. But linear models like ridge regression and lasso regression can also be actually be considered for deployment. They have a higher RMSE than the best performing models, but they have a better machine learning explainability and have a low computational cost or are computationally efficient. So this makes it a profitable trade-off. With this, I would like to end my presentation. Thank you.
Thank you, thank you. Perfect timing. Thank you so much. So jury, questions please.
So great presentation, Yash.
Thank you, ma'am.
So first of all, your enthusiasm towards participating in these hackathons.
Yes, ma'am.
So when did you start and how did you know so much about modeling?
Yeah, so I actually started learning data science and machine learning stuff from my second year. And I had got much interest in this field, so I kept on participating and learning more and more, and hence I learned a lot.
Okay, so you did some courses as well?
Yeah, basically everything is available on YouTube, so I don't prefer many premium courses or go for spending the money. So I use articles from Medium. Medium is a great source for learning data science, and also YouTube channels, I prefer it for learning.
Okay.
Yeah.
So what were the key challenges that you found while doing this exercise?
Okay, so basically
key challenges that you had, and you had to see experts or talk to experts or anybody knowledgeable in the field to move forward.
Not actually. Yeah. So I actually spent a lot of time in the modeling part. I tried improving my results on the leaderboard, and it was the most challenging part for me. Apart from that, data preparation part, and it was all easy. I think I've done it quite in less time. So that's it.
Okay.
Yes, ma'am.
Okay. Thank you.
I don't have a question, but Yash,
Yes, sir.
at this young age, the amount of confidence that you're showing, right? So, well done.
Thank you.
And keep it up.
Yeah.
That's all I wanted to say.
Thank you so much. Yeah.
Well, the look on the jury's face says it all. So, job well done. I would like to welcome Colonel Gopal Karunakaran, Executive Director, Shiv University. Thank you for taking the time out to join us. And with this, we come to the last finalist for today. So Jagrut Pradeep Lalwani, student at Veermat Jijabhai Technological Institute. He's been selected as a summer intern analyst at Goldman Sachs and has also interned with IIT. He has performed automatic topic modeling and classification of data using deep learning and NLP techniques with more than 90% accuracy. So, Jagrut, are you ready? Yeah? You don't have the mic with you yet? Okay. This is the last presentation. So Jagrut is joining us any moment now. I do feel that all of you enjoyed the presentation simply by the fact that I did not see even a single, sleepy nod even at the back. So, that's commendable. Jagrut, all good to go? Yeah? All right, all the best.
Thank you. Does not work. Okay, just work. Good afternoon to one and all. So I'll just directly jump into this in the interest of time. Right, so this is just the basic data understanding part. So these are all the features: item ID, item weight, item fat content, item visibility, and all these. So below is the categorical featured distribution. So number of unique values for all these features, which is the topmost one, and how frequent are the topmost ones. So I eliminated that item ID because basically it was 896 unique values, and it was kind of redundant for me to have multiple item metrics contributing to the same thing. Like, for example, we have the item ID as well as the item fat content. So I felt that item ID was basically more related to the store, and not exactly, it was kind of redundant to have two different things pointing to the same conclusion. So this is the basic distribution. So if we can see that for the sales, the lowest value is minus 1229, whereas the standard deviation is 1291, and the mean is 1911. So well below mean, at least 75% below, like the 75% mean value in the negative direction is the minimum value for sales. So yeah. So this is just the distribution of all the numerical variables. Now outlet here, initially it was given as an integer type. So that is why it is shown in the numerical feature plots. I later changed it to string type to use it as a categorical feature, because it does not make sense to use 2009 as a higher metric value, because like any store opened in 2009 should not have more value compared to the store opened in 1888 or something like that. So yeah. Moving on, these are the normalized distribution of the different features. So first one is item fat content, and the second one is outlet type. We can easily see that at least 80% of the data points correspond to supermarket type 1, and at least more than 50% of the data belongs to the low fat content. So this is the normalized distribution of outlet ID and item type. So various item types and outlet IDs. Similar thing with outlet size and outlet location type. We can easily see that tier 1 has more than 35% contribution, and the small outlet sizes have close to 50%, belong to 50% of the data points. Now, in the previous slides, we had seen the numeric distribution of the years. So this is just the comparison of how the years play out in the train as well as test, because it may happen that the train distribution of years may be very different to the test distribution. So I did not want to have lower accuracies due to the different distribution. So if we see, the top 3 years for train as well as test are same, and the bottom 2 years are also identical. And so basically this gives us an idea that we are good to go with just doing training on the train set, and we won't find a stark difference. So we will get expected values while doing the testing part. So if we notice here, we did not have any data points for 2007 and 2005. So I just did another plot where we could see the different data points, basic scatter plot and the box plot. So there is data points available for 2005 and 2007, and they are kind of evenly distributed from 0 to 6,000. So yeah. Now this is just the basic outlook of the data. No null values were present, so I did not have to do any imputation as such. And kind of very less number of outliers for item weight and item MRP, which was seen for the distribution, so did not do any imputation as such. I did robust scaling, so which is standardizing using the interquartile range, which is the 25% percentile and the 75 percentile. So what we basically do is take the value, subtract it from the medium of that particular feature, and then divide it by the difference between the 75 percentile of that particular feature minus the 25 percentile. So that basically removes the skewness provided due to the outliers, and that the outliers basically would not be the driving factor of moving our expected value outside of the original value of sales. So yeah, basically combining the training and the test data before pre-processing, converting it outlet year into the integer type. Then all the features except item ID were considered. Dummy variables were created for all category variables, and the first one was obviously excluded because anything which does not come under the category of n-1 variables is definitely belonging to the last variable. As far as binning is concerned, I used binning only for light GBM model to set it to 200 for faster inference time. And then I did robust scaling here. And then after that, it was just split into 2 different variable types. The xtrain one, xtest one, and ytrain one are the original train test splits. And I just created copies and split the training and test into train and validation sets for the models like light GBM and XGBoost. So these are the models which I used, 5 in total, ElasticNet and Lasso. 2 of them are similar to each other. XGBM and light GBM both are gradient boosting techniques. I used also a neural network model, which is the MLB regressor. And the best summation, which was an ensemble of all the 5 predictions on the scale test train set, basically the robust scaling. So these are the hyperparameters which I used. Now, I did not do as such hyperparameter tuning for Lasso and ElasticNet. I used 2 different hidden layers, values 5 and 2 for MLP regressor. I did some hyperparameter tuning for XGB regressor and light GBM. So this is kind of what RMSE errors I got. So for ElasticNet and Lasso, I was getting almost similar, but as I move forward in my analysis, the features which contribute to these particular RMSEs are quite different. And for XGB, light GBM, and MLP regressor, we can see the accuracies here. Now, light GBM specifically, like I used ElasticNet and Lasso together for the fact that they are very close to each other as far as similarity is concerned. For ElasticNet, I have used 0.9 alpha for L1 loss type and 0.1 for L2, whereas Lasso represents only L1 regularization, and I also used alpha values of 0.1. So basically, it indicates that it is very close to the linear regression, therefore increasing its explainability. So coming to the feature importance, now feature importance is just the sum total of the absolute values and not the original values. So as I will move forward, you'll also see the original values as well. So right off the bat, we can see that item MRP, item visibility, and item weight were given the top 3 features, and the difference in the feature importance of the third and fourth is very high, close to 10 times of the fourth variable is actually corresponding to the third variable. And for categorical variables, 1996, 1998 come into the top 3. Moving on comparing it with light GBM, again the top 3 are for item weight, item MRP, item visibility. Again, the difference between the third and the fourth is around 10 times. But here we notice that item fat content regular, item fat content low, and outlet size medium bag the top 3 categorical feature importance. And this is the only model which has an outlier in this manner, that feature importance, categorical feature importance of 1996 and 1998 years of outlet were not featured in the top 3 categorical feature importance. Moving on, here we see a more distributed feature importance where categorical variables like 1998, 1996, and 1988 are given the top 3 spot. 2003 and 2008 also come in under the top 6 for both Lasso as well as Elastic Net. Again, the top 3 here are also the same, and 2003, 2008 are, again share the top part. Now, looking at the lower, feature importance variables, 1997 is featured in Elastic Net, whereas it isn't present in the low features. It isn't even present in the total top 25 features as far as importance is considered in Lasso. Now, this is the interpretation using the SHAP values. Now, basically, it is, as we all know, based on the different presentations here, that is based on game theory. That is, it is finding out the prediction of one variable based on the combinations of all the feature sets in which that particular feature is present. So here we can see clearly that item outlet year 1996, 1998, 2003, and item MRP are positively contributing to the sales, whereas outlet 18 at the top and it is outlet 18 and outlet 46, top 1 and top 3rd, are basically contributing in a negative manner to sales. And similar thing can be seen from the visualization for the light GBM. Again, outlet 18 and outlet 46 are contributing negatively, whereas 96, 98, 2003 are contributing positively. Now, if we notice at the limits, so it is going from -400 to 600 for light GBM, whereas for XGB, it is going on from 0 to 400, and no values are there to on the 600 part. So basically, we can also notice that for the years 1996 and 1998, the distribution is not that uniform towards the end. But as far as light GBM is considered, the distribution is more uniform and spread out. So that is why I chose these two models together to cancel out their effects and give a more generalized overview. Now, Lasso models, being the linear models, have a different visualization. Right off the bat, we can see that outlet, again, 18 and 46 are contributing negatively, whereas 1996, 1998, 2003, even though not at the top, but still contributing positively. Again, focusing on the limits here, it is still 300 to -300, whereas for Elastic Net, it is a more conservative approach because we are also using L2 regularization for 10% contribution of the features. And similar basic distribution. And item type fruits and vegetables is a new entrant, which was not present in the Lasso visualization. Moving on, this is for the MLP regressor with the 2 hidden neural layers. Now again, 18, outlet ID 18 at the top can be seen to contribute negatively towards sales, whereas new entrants like 1999, 1997, outlet 35, even 35 is contributing positively, with similar likes of 2003 and 1998 contributing again positively. So basically important points again are like for XGB regressor and light GBM, item weight and item MRP were the top 2 features, whereas categorical features like 1998, 1996 are the top 2 features of Elastic Net and Lasso. While there is a huge gap in importance of the top 2 features for Elastic Net, for the XGB and light GBM, a sort of more generalized distribution was observed in Lasso and Elastic Net. And also outlet year 1999 was given higher importance than item weight and item MRP, which were kind of the prime features for the 2 initial models, which is the XGB and the light GBM. whereas it has zero importance in lasso and negligible importance in light GBM and XGB. So again, as ElasticNet and lasso are regularization models which are very similar to each other, they have been ensembled together. Now ElasticNet has two kind of balancing features for lasso. First one is it can counter the small bias in lasso model where prediction is too dependent on few variables or a particular variable. And minor difference in regularization gives us also a more balanced prediction which does not easily eliminate high collinearity coefficient. Now lasso is generally known for removing all the highly collinear features. Now that won't be the case for ElasticNet, and as we also saw that the distribution was also more moderate as far as ElasticNet is concerned. Similarly for light GBM and XGB regressor, and I used Adam optimizer for MLP regressor. As far as business insights are concerned, feature importance of ElasticNet and lasso also help us to gain some understanding like, these are outlet tier and outlet ID should also be considered, which otherwise would have been overshadowed if we just use the XGB models, like the gradient boosting models. And MLP regressor also asserts this fact because initially I did a submission which was assembled using only 4 models, light GBM, ElasticNet, lasso, and XGB. Whereas on adding the MLP regressor, I was again getting a better RMSE score, which was close to 1269.8. So it improved my RMSE score for both train and test. Therefore, the analysis is moving in the right direction. And again, even if we want to deploy for faster inference time, we can just include the light GBM, MLP regressor, and ElasticNet and move forward with it. As light GBM has training time of 7 times compared to the XGB regressor. As far as the points concerned for recommendations, outlet tier outlet ID 46 and outlet ID 18 were kind of negatively contributing, and outlet tiers 2009 and outlet tiers 1988 were also contributing negatively to sales. So basically, we can say that if we look at the fact that outlet year 2009 is contributing negatively, whereas outlet year 2008 is contributing positively. So we can just go towards the, branches of outlet years of these two, outlets, and just compare what internal difference are there, and then we can come to a conclusion of why outlet years, outlets opened in 2009 were not that efficient compared to 2008. And again, for outlet IDs 46 and 18, we can also compare them with the other outlets, which is 35 ID, which was...
And that has to be a wrap, I'm afraid.
Sorry, contributing positively.
Yeah. So over to the jury for any questions. No questions?
Thank you.
Well, thank you. So with this, we come to the end of all 10 presentations. And I would like to take this moment to welcome the person at the helm of affairs of Shiv Nadar University, Dr. Rupa Manjari Ghosh. So Dr. Ghosh joined Shiv Nadar University, Delhi NCR in July 2012 as the founding director of the School of Natural Sciences and the Dean of Research and Graduate Studies. She took over the role of the university's Vice Chancellor in 2016 and has since been at the helm of the university's growth with a transformational leadership. Prior to joining the university, Dr. Ghosh served as the Dean of School of Physical Sciences at Jawaharlal Nehru University, JNU, along with many other important academic and administrative positions there. She has held several visiting faculty scientist positions on invitations abroad and delivered numerous invited research seminars. Also the recipient of the Stree Shakti Science Samman for her original contribution to science. She serves as an expert on the Department of Science and Technology, DST, Government of India Committee in Physical Sciences, and in many central and state universities and institutes. She received the DAE, Department of Atomic Energy, Government of India, C.V. Raman Lecture Award in Physics in 2018. Having contributed to science research and training from the university to the school level, she has also served as a chief advisor for the National Council of Educational Research and Training, NCERT, for science textbooks all the way from class 9 and 10, developed afresh under the National Curriculum Framework of 2005. She co-chairs the Federation of Indian Chambers of Commerce and Industry, FICCI, Higher Education Committee, and is currently a member of the Council of the Inter-University Center for Astronomy and Astrophysics, IUCAA, Pune. Dr. Ghosh has a Master of Science degree in Physics from the University of Calcutta, India, and a PhD from the University of Rochester, New York, where she worked as a Rush Rees Fellow, selected for outstanding scholarly ability and the promise of exceptional contributions to scholarship and teaching. As a researcher, teacher, orator, and an academic administrator par excellence, Dr. Ghosh is well known for her stand and efforts to support the cause of gender justice and environment consciousness in the higher education system. And we are very glad that she's joined us here for the event. We welcome you on stage, Dr. Ghosh. And may I also invite all 10 finalists, and may I also invite Dr. Vivek Banerjee, please. May I invite all of you, please? We'd like Dr. Ghosh to, along with Dr. Banerjee, to hand out the mementos. Sorry. Yes, please. I mean, I just get the mic.
Thanks, Vivek. I'm actually quite thrilled. Didn't have the time to attend from the beginning, but whatever Dr. Vivek Banerjee has been feeding us with and the excitement in this room, it's really a good start for our ACE. You know, Arun is sitting right there. Under Vivek's mentorship and Arun's energy, the Academy of Continuing Education today actually has been, launched this very fantastic program. Data, as they say, is everything. It's like the oil in this century, right? And analytics probably would be like the combustion engine or better. And as they say, I attended only the last presentation. If you torture the data enough, it will ultimately confess. And I think I saw some of your plots, that confession. So I think you have been really doing that torturing of the data enough. So I think it's been a great start. I wanted to thank the jury for sparing their time to do this, it's a grueling work on a Saturday morning. But congratulations to everybody who participated. I'm sure Vivek will choose one winner, the jury will, but whoever participated is a winner. I think the learning to take back home. Definitely Shiv Nadar University is enriched today because of your participation. So I think I thank you for that and congratulate you. The very bright team of our School of Management and Entrepreneurship led by Vivek, and now part of also ACE. My congratulations to all of you. So let the suspense be lifted and let's get to know.
Yeah, it will take a while. They are still doing they're deciding the fate right now.
Okay, so I think for those of you, I think Shiv Nadar University, 6 years back when you talk to people saying, well, I've taken over and this was not my retirement post. You embarrassed me by this long introduction, but I came here leaving a comfortable government job, resigned from there to take up this challenge 10 years back when this university started. And even 6 years back, if you ask people, Shiv Nadar University, or I've joined there, they would say, what? Who? And now you mention Shiv Nadar University anywhere, and they would say, well, it's one of the best. And, parents write to me saying that I sent my first son to study in your biotechnology program 6 years back. At the time, all my friends told me, where are you going? Choose one of those stable government places. And I've entrusted my second son also to you, this time in electrical engineering. And now that when I mention Shiv Nadar University, they say, wow, it's one of the best. So I think this couldn't have happened without what all the elements you see. Of course, it all started with a founder who is very, very generous and had a vision. And then the people, the buildings here, the campus is beautiful, but whatever we do inside the campus is more beautiful. And I think that needed all the people that you see here, some section of it, completely multidisciplinary, which would feed very well into our ACE. This education, the continuing education, today's world really talks about multidisciplinarity in a very big way. and we don't do just a lip service to it. We truly mean it, because ground level problems of the kind you are looking at need tools and grammar from all disciplines, and you need to know where to find it. You don't have to know all. So I think it has been quite a journey for us in 10 years. Very proud to say that now we are one of the few institutions of eminence in this country. That also sometimes gives me nightmares for the future, because it's one thing to get the tag, it's another thing to prove to the world that this was part of our vision anyway. And it's totally faculty driven. Whatever we are today is really because of a very dedicated set of faculty. They're bright, trained in the best of places, and then equally bright-eyed students. These are the two components, and those who work silently behind the scene are our very, very committed administrators and support staff. So all three units together, along with the vision of the foundation, I keep saying it, that one man's vision has become our collective dream, and I'm very lucky to now add more to that set of collective dreamers. So if the jury is done, then I'll stop talking and get the announcement going. Some more time.
I really wanted was all the participants to receive the memento from you. So may I have all the participants on stage, please?
Thanks a lot, and congratulations.
Please. Please, you go on stage. So the memento. Rashmi, can you? Yeah. So I will call upon Vivek Kumar. And next, I would call upon Akash Gupta. Then Rahul Patnekar. Mukul Sharma. Rupesh Prasad. Rajat Ranjan. Indrashis Das. Yash Khandelwal. And Jagrut Pradeep Lalwani. And it's been quite an accomplishment for all of you, all 10 of you, to really be here after, the nationwide hunt and the struggle and the contest that all happened. And that is why time and again, we want to emphatically lay home the point that, all of you are winners. But of course, there has to be some murky mystery further, and they will tell you, which of you emerge as the champions out of a lot of you. So we'll just wait for the jury. I'll just check, and you can have a seat. Sorry? Jury will take time?
We should get back.
Yeah, that's what I said, yeah. So think of it as the lull before the final storm. So jury will take just a little bit of time to kind of come with the final results.
Now don't call everybody on stage.
The unique value proposition of the School of Management and Entrepreneurship at Shiv University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs so that our students emerge as theoretically grounded, practical problem solvers for the digital world. Shiv Nadar University is a comprehensive, research-focused, student-centric university that is focused on student outcomes. And the School of Management and Entrepreneurship sits smack in the middle of that ecosystem. Machine learning, there is a concept of meta-learning, which basically means learning to learn. Much of our educational philosophy at the School of Management and Entrepreneurship at the Shiv Nadar University is to attempt to create a meta-learner among our graduates. There are two aspects of education we believe that is going to drive the future. One part of that education is going to be changing over time, such as tools, such as techniques. With the pace at which the digital economy is evolving, the rate of obsolescence of those tools and techniques is very, very fast. There are certain unchanging aspects of education, which is deeply rooted in the theories and the fundamentals and the first principles that are relatively unchanging. So this balance between the unchanging and the changing aspects of education is very much a guiding force of most of our programs at the School of Management and Entrepreneurship. And the blend is largely geared towards creating a student outcome wherein they become lifelong learners and they figure out how to navigate the environment to how to stay relevant and ahead of the curve as the most uncertain future unfolds. The COVID has changed the world fundamentally. The old models of education based upon rote learning, based upon use cases, based upon examination, is now defunct. There is wide-ranging agreement that education needs to be re-examined, needs to be reimagined to create a leadership that would drive the future economy, which is going to be heavily driven by digital technology. So in our school, what I am attempting to do is to reimagine, reboot that curriculum and the model of business education, wherein this whole aspect of entrepreneurial trait with a clear focus on the digital technology takes the center stage of everything that students do here at the School of Management on Entrepreneurship. So at the School of Management and Entrepreneurship, we will be working with people who are invested in becoming leaders of the digital economy.
Nadar University, is being built on a few very important pillars. One of the pillars is multidisciplinarity. The second pillar is project-based learning, and the third piece is to be research-driven, right? So if you look at this trifecta, these three vertices of this triangle of multidisciplinarity, learning by doing or project-based learning and being research-driven, the data sciences course that you are about to launch into checks off on all of those three vertices. You probably have at your disposal the best of resources. We are quite happy to be partnering with Jigsaw Academy, who are very well reputed in the field of business analytics throughout the country, ranked #1 in the country by multiple ranking systems.
More and more, data has become so central in ways we live, things we do, decisions we take, that it's almost impossible to get around without that. And here, what we have done is we have assembled a program that brings all the necessary tools and things about how to apply in some contexts, right? And that's the beauty of this certificate program that has been designed especially for you guys.
Data science uses the best of multiple worlds, and it uses elements of math, stat, computer science, economics, natural sciences, fields like related to biology, like bioinformatics, genetics, genomics, as well as the modern nanoscience and nanotechnology, you name it. It's from a practical perspective, it will open up a wide variety of work opportunities for you in the industry as well as in the academics.
Shiv Nadar brings enormous amounts of intellectual firepower, which complements what we do at Jigsaw. And I think together it's just amazing. And I've talked to these guys before. They're just insane amounts of intellect there. And we try to bring in the industry piece and the applications piece and create something. We have tried to create something which should be extremely useful for all of you guys. And as Jadip mentioned, not just for your jobs or your resumes, but for real life.
So I wish you all the best on that. And I'm also wanted to share with you that we are expecting full commitment from your side, because from our side, we promise you full commitment.
The unique value proposition of the School of Management and Entrepreneurship at Shiv Nadar University is in its very name. Here we do not merely teach management education, we attempt to create an entrepreneurial mindset in a digital environment, which we believe will be the future of learning. Our vision is to merge the polarities of theoretical rigor and practical execution of business in all of our programs so that our students emerge as theoretically grounded.
So the results are out. Can we have everyone join us? Jagmeet, can you just, everybody to just come, yeah. Let's get around. Yeah, just waiting for like a couple of minutes. Just, yeah, okay. So the jury's all here. Are all the participants here? Do we all 10? Anybody missing from the group? I think all of you here, right? Okay, great. So we get back to the grand finale of the grand finale. But first, we'd like to hear about the overall perception of the event and the answers and the whole interaction that happened. So we'd like to invite the jury on stage. So I would first like to invite Dr. Jain, please. If you could just kindly come on stage and we have a mic. Please come. Yes, please, whatever. I mean, your overall, yeah, feeling about the...
Okay. So, first of all, thank you to Shiv Nadar University, Dr. Vivek, for such a grand show. It was quite a pleasure to be here for this entire day, a day very well spent. It was also, I think, for each of us who witnessed this contest today, it was a lot of learning. Even as professionals in the industry, I was just imagining that a single problem, when a client problem comes to us, what are the different ways of solving it? So it just opens the possibilities. Just not like one way of solving, but so many different parameters of solving, and just knowing that we know this very well and yet we don't know this. So I think that came together. Secondly, I'll just like to congratulate all the finalists. It was, I think, an extremely difficult task to find out the names of the winners. As the jury members, we had differences of opinions. Ultimately, yeah, it was the final score which went through. But I just want to say that it's not only the winners. I think everybody did amazingly well. So that is great. Thirdly, I would just say that as many of the questions span, as most of you are in the professional world, the students are going to get through. I think there's a lot about AI, ML. Is it really impactful? Is it really impacting? Or is it just the hype? I would just say let's remain focused to the outcome. As long as we are able to even make a little bit shift in the outcome, it is definitely meaningful. What happens is that as data scientists, all of us take pride in complexity of the algorithms. That should not be. It should be the impact that has been created. So that is the only thing I want to leave this group with. And the other thing, on a personal front, I would say that keep this learning mindset on. I think learning is the key in this new world because things are evolving every day. And I'm sure that this group of finalists definitely has a great learning mindset. And competitions like this are impacting in multiple ways. I think it just helps us connect with like-minded individuals, gives us the possibility to collaborate and to do much more. So keep it up and keep up the great attitude. That's all from my side.
Thank you. Thank you. That's very encouraging. And may I request Dr. Anish Agarwal to please also come on stage and share his views.
Good evening, everyone. First and foremost, okay. Good evening, everyone. Am I audible okay?
You can try this one.
Check, check. So first and foremost, I'd like to congratulate Shiv Nadar University and, of course, the ACE for successfully hosting such a mega event. Perhaps from an industry standpoint, we really need events like these. And I'll take some time to explain sort of, or to share an instance. And this relates to a guy called Gary Kasparov. I'm sure everyone would have heard about him. Gary recently authored a book which is Deep Thinking. If you haven't had a chance to read, please do take a moment and read. And Deep Thinking as a book is all about the conversation or the battle between machine learning, AI, and human beings. And I recently read that book and I quite liked the opening preface and perhaps the scene setting where Gary shares his experience. And this is dated 1992 when Gary was right at the top of his career, understood as the chess master, undefeated by anyone across the globe. And there was one company which invited Gary and challenged, you know what, we'd like you to play a game of chess. And the unique thing about that game will be you have to play with 32 players at one point in time. So 32 games versus 32 players versus one player, that's Gary. And Gary said, yeah, that's fine. I'm happy for that challenge. And he accepted that challenge as well. And he ended up winning each and every game. And that is what struck a few of the tech giants at that time. And IBM invited Gary in 1997 to play a game of chess with a computer. Gary said, yeah, that's fine. If I can beat 32 players in one game, I can definitely beat computer as well. And then there was a lot of marketing publicity around that game that, okay, man's playing versus a machine, and Gary was super confident. But eventually Gary lost that game. He couldn't win the game against the computer. And that is when he said was his moment of realization that end of the day, and he said that when he read articles in the newspapers about his defeat, there were articles with headlines, computer defeats man. Well, he said, my reading of that article or that instance is different. It was not man versus computer, it was man versus man. Eventually, it's human beings, it's a man who has made the computer. And the reason I wanted to place this or share this story is this is exactly what happened today. There were 10 different individuals who shared 10 different views on a common set of problem, with 10 different approaches, 10 different strategies, with a mixed set of tools and outcomes. Few had different recommendations, few used different tools. And that is the beauty when you organize events like these. You get several perspectives. You get an opportunity to not just witness, but to learn as well. And this is what makes events like these extremely beautiful and exceptional. Thank you very much. And congratulations to the participants. And I'm sure as we announce the winners, we will get to know this as well. Thank you.
Thank you so much. Thank you so much. That was very heartfelt. Megha, would you join us on stage, please?
Good evening, everyone. At the very onset, thank you, Shiv Nadar University and Machine Hack for organizing what you did today. We all have been hearing that, data science, AI, ML, that's quite becoming the mainstream. Yet, we see very, very few businesses actually adopting them in their production environments. And why is that so? Because I think as a community, there is a lot from us to be done in terms of convincing the business, in terms of influencing them, that the returns on investment that they make on their data science initiatives is going to be high, and it's going to reap the right benefits, right? And so from that standpoint, with the group of people we have here, who are, some of you are in college, and some of you are with few years of experience, there are three things that I would like to call out. First is with regards to problem solving. So when we look at a problem, I think it's more important for us to understand the what and why of a problem rather than straight away jumping into the how of a problem, which very well relates to the problem statement we had today. So we are forecasting the sales for retail stores and outlets across the board, but why are we doing that and what is it that's going to lend to the business is more important to be called out to your stakeholders. That's the first thing. The second thing is with regards to presentation skills. I think it's very important to break the monotony when you're presenting, because you have one problem statement, 10 different people presenting, almost similar ideas, because I think all of you are very, very close. And life is all about relative grading, right? One versus the other, no matter how much we may want not to accept that. So breaking that monotony is very important, and never alienate one section of the stakeholders. So you have business, you have the technical people, you have to have a balance in your presentation. That is the second thing. And the last thing, of course, is with regards to how you would take your career, your journey here. Corporate life can be brutal. At the same time, it could be a bliss if you take your life as a journey with milestones and not just as a destination. So keep learning, keep growing, and keep doing good in life. Thank you.
Very well said. Thank you. And may I ask Manoj Manusudanan to join us with his erudite views.
Thank you. When you are the fourth speaker, the challenge is when everyone speaks, okay, I'll speak that other one, then that's ticked off, then the next one, that's ticked off. I had problem solving, that's also ticked off, so nothing left for me to speak. But first of all, thank you, Shiv Nadar University, and for inviting us as jury panel. It has been a pleasure being here. You've been great host, great hospitality. We really enjoyed every moment of our stay here, including fresh air that you don't get much. I'm coming from Gurgaon. Day has been absolutely well. I got up at 5:30, but I'm still awake. That means all of you have really done a great job in presenting your findings and kept us fully awake. Professor Banerjee spoke about the number of people registered to this. If I remember correctly, 1,000 registrations, 250 submissions, and now we have 10 people from across the country. So just look at the whole funnel. So 750 people registered, but they didn't have the courage to submit something meaningful. And then finally, from that 250, you are the cream, the 10 people from across the country who are here in this room. So everyone is a winner. That's the first point I wanted to just make. So I just want to give a big hand to everyone for winning this. I don't want to talk a lot. The only thing is, Megha, with your permission, I'll talk about problem solving again. So essentially, one thing that you should, and this kind of I felt through the day. I think you've all been solving this problem given to you in your own ways, to varying levels of depth, breadth, all of that. But one thing I would say is, before you, as a data scientist, we always have the tendency to jump into forming a hypothesis, jump into exploring, jumping into, let me find the features, then train, validate, test, all of that. Resist the temptation. Think like a layman and start thinking about what does the business want? What is the problem that we are trying to solve here? There is a technique called Ask 5 Whys. So basically, you say a statement. It's a nice game to play. If you have some young children at home, you can play that game also. Ask a question. Children always do this. They ask why. And when you say something, they'll again say why. If you have a toddler at home, you'll know what that means, right? And then why? You have also done that, all of us in the room, irrespective of our current age. So why? Ask that question. When you are solving a problem like this, before you get into any hypothesis, ask this question, why? Get into the root cause of what the real problem is. Okay, sales needs to increase. What does that mean? That sounds like a very broad term. What does that really mean? What are the drivers of that? Does it mean that, volume sales, dollar sales? Or does it mean that you're looking at sales such that your stockouts don't happen? Whatever, right? You just get into the details of the problem by asking yourself the question before you even get into the data. That's the only thing I would say as a kind of a focal point for you to really, I mean, as we know, AI is going to change the world, and you are right in the middle of that by becoming, by showing your mettle in this space, right? Elon Musk may have a very outrageous view of things. I may not take that view, but even then, I think over the next 50, 100 years, there is a nice book that you should read, 21 Lessons for the 21st Century. It's an amazing book. It again gives you a lot of very interesting perspectives on how the entire idea of democracy, free will, rational thinking, all of that can change with AI coming in. So it is something that can question the human race's existence as we know today. And you are in the center of that with your skills. But if you don't add problem solving to it, then I think you might just be, you will be a machine that they will overtake. So just that's the only point. Thank you again. Thank you very much. Really enjoyed being here.
Thank you so much, Manoj. That was profoundly philosophical. You definitely stirred something here. And it's very accurate as well in the context, in every context, frankly. And after all the kind words, it's time to really get brutal. So may I invite Dr. Gopal, please, Colonel Gopal here, please. My bad. Please. And can I have the second runner-up, Chit? Do you have the name? Please come. Yeah, please.
I'll break the rules. Colonel Gopal is the real engine around which this campus goes around, first and foremost. So he's the executive director of Shiv Nadar University, has been the CEO of Shiv Nadar School. Yeah, still am. So that's his other position. So very instrumental in building Shiv Nadar School, about which we spoke about. Gopal is a great friend and a sports enthusiast. So we were talking about, these people were taking a morning golf cart route, and they stopped at the biological park, and they entered the park, and that's where their campus tour got truncated, I believe, because in the interest of time. So I'm requesting you all to visit the sports center. So Gopal is a live wire, the spark that keeps it all going, and and he's been an architect of much of what the last, Gopal, you've been 2 years, 2.5 years here at the university. So thanks for being here. So thanks for giving out some of the, a few words would be nice.
I had no intention whatsoever to speak. I did check that I had to only stand and give away something, but I think I will. Firstly, my first impression of sitting there and listening to the last 2 presentations was, and I messaged a friend who's on the campus, Anuba, and said that I've realized just now that I don't even understand 1% of data science, which was the impression I had when the presentation was going on. I couldn't understand a thing. I spent all my life in the army, and just to carry on from what, but I must say that I understood at least and learned a great deal from what the jury spoke of. So it didn't look so bad. So there was a lot of wisdom for everyone here. I think I sincerely miss the fact that maybe we could have had students, in the background. I hope all these videos go there because it'll be invaluable to students at SNU. And I was wondering, why are there no more students listening to, if not, I couldn't understand there, but they would have benefited greatly from what is going on. And I'm sure from the problem solving things that, the finalists, the top 10 presented, I'm sure there'll be great value. There's only one caveat, I think, to data science. I spent all my life in the infantry, which is decision making, which has to happen very quickly. But one of the things we learn very early is that you have to take decisions with about 70% data, and you have to leave a lot, 30% to intuition and to gut. And regardless of everything which happens in the world, as COVID has taught us, and so many things about the economy which has taught us, there are a lot of black swan events which will keep happening, which will be so sudden, which no data is going to help you analyze unless you listen carefully to what the jury said, that there are many elements, I think, in problem solving, which is beyond data. I think that's also a very important part of the lesson. But congratulations to all of you to just get to the final 10. I shouldn't say congratulations to Shiv Nadar University, but it's such a fine event that the business school has put together and Jigsaw has put together. So thank you so much.
Thank you, Colonel Gopal. And so now the cat will be out of the bag. So let me ask the collective wisdom of the finalists. You know, who among you think, you know, emerges as a second runner-up for today? Any guesses?
They all competes.
Any guess? Any forecasting that you would like to do? Nah? All right.
Oh, there? Okay.
There it is.
This is the second runner-up?
Yeah.
There are two runners-up and a winner, right?
Yeah, second runner-up, first runner-up, then a winner.
So the second runner-up is Rahul Pednekar.
So now we will have the first runner-up. And again, any guesses, or still you don't want to take any names? Any guesses, seriously? Nah? So we'll get more crew now. Just. Is this low? Which mic is working? Yeah, this one.
It looks like the Film Awards night or the Miss World, but anyway, the first runner-up is Yash Khandelwal.
Congratulations, Yash, Tusi Chhagae. May I now request Dr. Banerjee kindly join us on stage? Winner. And Mike. I'm sure you won't like to guess this one, but
wow.
Unexpected?
Any guesses? No guesses. I mean, we had so much data, but no recommendation. So the winner and the winner of the event is our only female candidate, Arpita Sagar.
Whoa! the winner gets a cash prize of rupees 1 lakh. Whoa. Way to go, way to go. And kindly just be on stage. I just request the other two runners up to please just join us and we'll just have a collective photograph. So you can bring your trophies and all along. It's really like, they're nice, I think. Can I have Dr. Ghosh join us, please? Yeah, for the... Colonel Gopal, please. And with this, the Analytics Olympiad 2021 comes to an end. And I thank all of you, literally all of you who sat through the entire session. And I got feedback from everyone, from faculty, from jury, and from a lot of other people in the audience that they really enjoyed all the presentations. And it was really a tightly contested thing. And I really thank the jury for their patience and their accurate observations on how things unfolded and all the inspirational words they also said. And I definitely thank SNU leadership for taking out time on the weekend and being there because frankly, that's the inspirational bit that helped move things. Yeah. So I was just saying, it's just all good and we appreciate it. So Dr. Banerjee will now deliver the punchline.
Yeah, no, just not a punchline, just a vote of thanks for first and foremost. I mean, once again, like in the morning, I'd like to really express my gratitude to each of the members of the jury. It's very important, as I keep saying, and we stand for entrepreneurship. This is the first event, and our plan is to make this an annual event. And I keep saying that one of the most challenging things in any entrepreneurial initiative is to get the first customer or a first stakeholder. So you are them, really. We are lucky to have more than one. Of course, the participants, I sat through some of the presentations, and I can tell you that the work of the jury couldn't have been easy because all of them looked equally good to me and all that. And I hope to remain in touch, and we hope to meet again next year on this event for sure, around this time of the year. I just wanted to let you to share with everybody on that this event would not have been possible without the enterprise, the sweat of a whole bunch of people, and I do want to acknowledge all of them. First and foremost, of course, my colleagues from the leadership, Rupa, thanks for taking time out on Saturday. Gopal, as I said, like Gopal is a sport. I have also been a sportsman, and of course, it's unfailing. He's terrific, even at his level of engagement, that he manages to, bring all aspects of leadership from sport into real life and, of course, the army. So thanks, Gopal, for making it. Arun Gupta, he is the Associate Director of AS. Arun is the man behind, you know, a lot of what went on today. Thank you, Arun. It's been, from what I'm hearing, I think it's been a very well-managed day, and it's always good to start out on the front foot on most innings. So all those who you see on the sides, Rajat has been our, you know, very well-spoken MC for the day. Thank you, Rajat, for the whole day. We have Tusha, Rashmi, Jagmeet, and Jyoti at the front. They have been, you know, all that went on, and as we say that any well-managed project, you know, that has a hallmark, and that there are some things, some people you don't notice, and that's the hallmark that you know, things happen without too much of a hullabaloo. So thank you very much for all that terrific enterprise. There are some people at the back. Winky, you know, she's the tallest lady on campus, very easy to spot. Sumail, the handsome turbaned gentleman you see at the back, have been, you know, instrumental with a lot of the logistics as well as the publicity of the event and engagement. And of course, Laksh Kabra, Laksh is the tall chap at the back who needs to spend some more time in the sports center. You know, Laksh manages our postgraduate admissions, and you can be sure that he will be in touch with you and trying to deepen the relationship that we started. Who am I missing? Am I missing anybody? Amit, thank you very much. So Amit is our, you know, our school on wheels. So he is the chief messenger for the school. Who am I? And of course, another chap who needs to spend more time in the sports center, Rajesh Maji. You know, he's been another live wire for the whole show. Our partner from Analytics India, Krishna and Shajuti, if you'd please raise your hand. I hope to share a cup of coffee with you now. I haven't had a chance to meet you, but thank you very much for all that. I've kept in touch with everything that you guys did with respect to setting up this event. So thank you very much. Thanks to Analytics India, and of course, you know, last but not the least, the faculty team from SME, you know, led by our Zen master with his hands up over there, Kaushik Chaudhary. So thank you very much for taking your Saturday off to be part of this initiative. So with that, I think we have all earned ourselves a cup of coffee and some, I believe, some more, Arun, some more healthy and unhealthy snacks. So thanks very much, and to all the participants, I hope you enjoyed it. Be safe, and I wish you all the safe travels back to where you came from, and hope our paths will cross in the future very soon. Okay? Thank you very much.
Show still not over, boss. Please be on stage. I will request everybody in the hall to come on stage.
Sure. I think one person that we all feel that we haven't spoken about as a team is Dr. Banerjee. And I mean, thanks to the fact since the time he's been here, he's been the real, you know, power behind, you know, letting us not sit, keep thinking, you know, keep revisiting how can we do it better. So this is from all the team. Thank you so much, sir.
So kindly join Dr. Banerjee on stage. Everybody, kindly, we'll have a massive photograph, and we'll justify the size of the stage. Please. I think some of us are like getting in. Can you all spread out a bit? Like this, I don't know. सब आ रहे फोटो में? नहीं आ रहे ना? कोई लोग हमारे पीछे बैठ जाइए.